let's start installing the SQL Server product on your computer. So, as a reminder, SQL Server is the product that will install the database engine on your workstation. Okay? It can be on the server on your hard computer. Personally, I have a Windows 10 computer, which is not very powerful. It has only 8 gigabytes of memory, a classic CPU, a Core Intel i5, so it's not very powerful, but it's a computer that will be enough to install the engine. Okay? Don't forget that the 2.exe files to install the Management Studio and the SQL Server product are attached to the course. They are two completely free projects. Okay, we start with the installation of SQL Server Developer Edition. Okay, this one. Okay, double click on the .exe. Click on Run, and the Windows appears. Okay, here by default, when we launch SQL Server 2019, I always take the basic installation type. No need for custom or download media. Okay. So then they ask you to accept the terms of the contract. We accept that. So in my case, I don't have enough space on my C drive. Okay, so I'm going to change it and put it on the G drive. It's not very complicated. Up. Okay, it's good. This has no effect. If you leave the installation on the drive C, of course, you can even leave the default path. It's not very important. Okay, I click on install, just here. I'm going to pause the video because it's going to take some time. I will resume it when the installation is done. Okay. Once the download is complete, you will see a window that tells you that the installation is complete. Okay. Here we have on the left the installation name, instance name by default, the ideal instance, and so on. Okay. We will see that later. To avoid this, we need to do a customize. Just here, customize. A Windows appears. It concerns the updates. I don't have any update to do. Maybe you will have to do some, but you don't have to do them right away. You can go directly to the next mode. Afterwards, you have a kind of validation that will check if the extension is well done in relation to the small component you have on your workstation. Okay? Once you have successfully completed this step, you can click on Next. After that, we have the installation rules. Here you have two choices. Okay, perform a new installation or add features to a SQL Server 2019. Okay. For you are going to perform a new installation. You leave all this by default. Okay, we are not going to take care of it for the moment. We click on Next. since the developer version is the free version, you leave it by default. No need to enter a license number just below. Click on next. You accept the terms of the contract, accept and click on next. And then a window appears. You have to check service database engine, just where. Okay, database engine service. Okay, this is what will install your database engine on your workstation. I am not going detail everything underneath. That's not the point at all. You just going to check that one. Okay. Click on next. Next. A new Windows appears. Here you have the default instance. Okay. Just here. Or a new named instance. Okay. What we call an instance on SQL Server, it's an installation of your SQL Server engine. Okay. It's important to know. Okay. It's an installation. When you hear this term, it means just an installation. So we are going to take a name instance and we give it a name formation and click on next. This brings us to the server configuration. Okay, by default you leave everything. Don't try to add service accounts that we put on the server, since if you install this on your computer, it's useless to put special account if you are a server, put service account that will launch SQL service. Okay, so click on next. Okay, there are some very interesting things there. There's two authentication mode: Windows authentication mode and mixed mode. Okay, we're going to put mixed mode, and we put a password as you want. I put a password, sorry. And click on add current user. As you can see, it's me. Okay, I am the SQL Server administrator. Okay, so click on next. And there we have the summary of everything you are going to install with the install buttons, sorry, just here. Okay. You can see that we have done practically nothing. We have just made a few modifications. You can see that the installation is quite simple. I'm going to click on install, and the installation can take 10 minutes or more. It depends on the machine when you have installed the SQL Server engine. Okay, and now I will show you how to install Management Studio in the next demo. Okay, so we installed SQL Server on our workstation or on our server. Now we are going to install Management Studio. Okay, just here. Okay, we click twice on it. I'm going to pause the video to save time. And a Windows appear. I click on Run. Okay, you will see that the installation is not very complicated. I took the version, the release 18.7, sorry. Click on Install. If you have Hover Management Studio installed on your computer, there is no problem. You can install both at the same time. If you have a SQL 2019 version in Management Studio, there is no problem. You can install the one that is the most recent. Okay? So we'll install it. It will load the package, and I pause again the video. Okay, it has finished downloading all its components. You can see that the installation is finished. Okay, you have seen there is nothing very complicated for the installation of Management Studio. Okay, in the next session we will launch Management Studio and we will connect to the SQL Server, and we are going to learn how to handle Management Studio. Okay, to launch Management Studio, right click on your Windows logo and then you type Management Studio. Search and Management Studio. Okay, let's make a zoom. Microsoft SQL Server Management Studio 18. Okay, I have the 2018. If you are another version, it doesn't change anything. Okay. Okay, let's launch the Management Studio. Sorry. Okay, here you have a notification mode. We are going to stay on Windows authentication. Okay, we are not going to talk about all that SQL Server authentication. And remember, we named our instance formation. Okay, just here. Okay, otherwise, another little trick, you can put local host. Okay, you delete formation and you type local host. If you cannot find your server, click on Browse here. Browse for more. And SQL will search for whole instance installed on your server. Okay. Usually the first authentication to the Management Studio is to connect to the database engine you install with SQL Server. So here Management Studio is going to be used to connect to the database engine to be able to do the administration on it. Okay, create database, manage security, write, performance, and everything else that follows. Okay. So it's your tool that going to let you manage all that. I press connect here. Press on connect. And I have a window on the left that appears. It's the Object Explorer that will allow me to see everything that's on my database. You can see, as you can see, there's on the database there's nothing. there at the moment, which is normal. You will see on how to create a database, and if you want to make a new query, you have to press on this to write you first transact SQL script. New query. Okay? Click on it. To work on transact SQL, you can call it the SQL dialect because it will allow to write query that SQL will understand. Okay? So we press before new query, and that's where we will write whatever we want. Auto formation. Okay? And that's where we will write our famous SQL query, a fantastic query. Okay, we also have a lot of tabs up and so on. We can do a lot of things with the Management Studio. Okay, this was the first example of installing and setting up Management Studio to show you how it works. Okay, now we are going to get to the concrete, the creation of the database, and now we are getting into the game. So let's go for the next demo and create the first database on new SQL Server engine. So what is the database? This is the good question. A database is a container that helps us to organize the data. Okay? It allows us to store and retrieve all the data in the database. We have, for example, many Excel files where all the data is captured. Why not to centralize all this data in a single database? Okay, it's in this example I have 3 Excel files that are scattered everywhere. I have to delete and modify the select Excel file, so I have to remodify it on the third Excel file and so on. It's a mess. Okay, the idea is to take the 3 files and centralize them in one database, which will be much more convenient. Okay, so it will be much easier to query the data, update it, and delete obsolete data, and so on. So to centralize the data, there is no better way than a database. Okay. An extra information, you can have 32,767 database on one SQL Server instance. Okay, remember that SQL instance mean one SQL installation. Okay, so come on and let's go to a demo right now. Okay, we have installed Management Studio, we have installed SQL Server. Now we are going to create our first database. Okay, we are going to do it in 2 ways. One at the graphical level and one at the transact SQL level. Okay. First, we are going to connect to the server and click on connect. Okay. And put the name of the server just here. So here, put the name of your server and click on connect here. Okay, connect. For the moment, you can see that there is no database in the Notion database. Okay, here database, there is no still database. Okay, so come on, let's go, let's create a new database. Okay, to create a new database, it's very simple. We click on right click and new database, and here we have the database name. Here, just the database name is here. Okay, so I'm going to put the name of my database in it, and I'm going to call it formation. Right click on the bottom right on OK. Click on OK, and at the top left the database formations appears just here. Your first database has been created. You can see that it's very simple to set up. Understand? So we are going to create a second database in an SQL query. That's to say we are going to write the creation of a database. So I click on new query, just right here, and we do create database, create with database, and I call it formation 2, and after that we press the execute button just here. Okay, so execute the query. So now we do a refresh on the top left on database, refresh, and I have the database formation 2, sorry, that appears here. Okay, so in this exercise we have created a database in 2 graphical ways, using Management Studio and with the script, SQL script, by doing create database followed by the name of the database. Okay, so let's go for the next demonstration. Okay, so in the previous video we see how to create a database. In this video we will learn how to modify or delete the database. Okay, the modification is done with the alter command just here, alter database with the name of your database followed with the syntax modify name and the new name of your database. Okay, so alter database formation 2, modify name formation 3. Okay, let's execute this query by the execute command. Execute. That was very fast. The database name here, formation 3, has been set. Okay, and if I do a refresh, right click on the database and refresh, you can see that the name has become formation 3. Okay, we can also do it graphically. Right click on the database and click on rename just here, rename, and we set formation 2. and it's good. Formation 2. Just here. Formation. Okay? And to delete the database, you have to do drop database. Okay? So we write drop, followed by database and the name of the database that you want to delete. In this case, it's formation 2. Next, execute this query with execute command. Okay. And we see if we are doing a refresh, we see that the database formation 2 had disappeared. Okay. So, in this demo, we saw how to rename and delete a database on SQL Server. Exercise, take your keyboard. Okay, so the first question, can you create a database called exercise? Okay, you create this database with Management Studio and by Transact SQL. Okay. Second question, then you will have to rename it to exercise 2 and at the end delete it. Okay. So go to your keyboards. I will give you the solution after this exercise. Okay, and I wish you good luck. So we saw what it was a database. Now we will see what is a table. In the database management system, a table is a relationship that can have relationship with other tables. Okay? It's what we call the relation database management system. So it's called a table or a relationship. It's made up of row and column. Okay? Just a row and with a column. The column is also called an attribute. Okay, in this table we will have rows and columns. The column will take the column name, and we will have rows that we are going to insert, where we are going to put the data in this table. Each row will correspond to a data record. Okay? So the syntax for creating the table is simple to write. The syntax is create my table with the name of the table. Okay? Following the name of the column. Okay? And with the type of the column. Okay? So let's go to the demo right now. Okay, let's go for the creation of the table. Use formation. So what is use formation? It simply allows you to use the current database. Use formation means use this formation database and then I create my table on this database. For the moment, we are on the master database, just here. Okay? So, I will use this command, use formation. Let's execute this query. You can see here that it has changed. Okay? Now we are on the formation database. We are working on this formation. I am on the formation database here. We will see that you create many SQL scripts. If you don't use them on the database, you will have an error. Use formation is going to be very convenient to use this database, and then to avoid writing other SQL queries on other database. Okay, it's a very good practice to start with the use followed by the name of your database at the beginning of a transact SQL. Okay, understood? So I do use formation. SQL comments. SQL comments here are made with 2 dashes. I put 2 dashes just here, and I can put my command. If I remove the dashes, it's not good. Okay, I have a error syntax. If I put just 2 dashes, the commands is now good. It's very useful while I am doing a callback on queries I have already written. So if I come back to it afterwards, I know what I did in that query. So here we saw how to use a precise database and dashes to add comments. So we are on the right database, so here we go. Creation of a table with 1 column. So I'm going to start with transact SQL. Create table, let's make a zoom. Create table with the name of my table. Okay, with the name of the column and varchar. Varchar is for strings of character. Okay, we will talk about it in the another session. Okay, so it's a simple table with just 1 column. Let's execute this query. Command completed successfully. Okay, so I go back on my Management Studio interface. I go on table and I see, and here we can see my table. It's just here, table, and my table is just that. Okay, so we create a table named my table with the transact SQL. And you can see the column names with the varchar. Okay. Okay, so I will do it with Management Studio. We click on new table. Sorry, new table. Okay, and the page appears with the name of the column. I will call it exercise, for example. With the column type and char this. Then I save the table here, just here. Save the table. And the page appears with the name of the table. I'm going to put, for example, exercise example. Okay. And if you make a refresh, your new table appears just here. Exercise example. So we learned how to create a table with Transact SQL and Management Studio. Okay, so now we are going to create a table with 2 columns. Okay, let's make a zoom. Okay, with 2 columns. Create table with the name of my table with two columns. Column names, Vashar 2000, and with a comma following the second column first name with Vashar. Okay? Don't forget the second parenthesis, just here. Okay? Because if I forget it, and I do, and if I execute the query, we have an incorrect syntax. Okay? Just add the parenthesis, execute this query. It's perfect. Command completely successfully. If I make a refresh, my second table with the name myTable2 is appears. It's good. Okay? And what if I remove the comma? If I remove the comma and I execute this query, we have an incorrect syntax near first name. The comma is mandatory. So we have to put the comma. Okay? So in this demonstration, we saw how to create a table with Transact SQL and with Management Studio. And that's not bad. Okay? Okay. Let's continue on the next demonstration. Okay, this part is about how to delete or rename a table. The modification of a table is done with the command the stored procedure sp rename. Okay, I will tell you about it in the following section about the stored procedure. Okay, so you need to run the command sp rename. The delete of a table, the deletion of a table is done with the drop table command. Okay, let's begin with the Transact SQL. We do sp rename. We are going to rename my table, my table2. This one, okay? Okay, let's go. Sp rename, okay? With my table2 rename. So in this example, it's my table2. With a code. Okay, so don't forget the comma between the whole name and the new name, comma, and the new name we want to give to the new table. So in this example, my table 3. Okay, let's execute this query. Execute. I have an error just here. Let's execute again. Okay, it's a good example. Use formation. If you are not in the good database, it doesn't work. Don't use the good database. I am on the master database. In the master database, the table2, my table2 doesn't exist. Okay, so use formation, as we saw in the previous demo, use formation. And if I make a sp rename again, now it's working. Okay, if I make a refresh on the top left, refresh. And now my table is called table 3. Rename with Management Studio, it's very simple. Right click on the table and rename, just here. Okay. I want to give to my table a new name, my table 4, and it's done. You can see that it's very simple to rename a table with Management Studio. So we rename a table with both way. Okay. In Management Studio and Transact SQL. Now I want to delete my table 4. I will do drop table. Okay, drop table like is the second example with drop database. So you replace database with table, drop table my table 4. And if I refresh the table, my table 4 on the right doesn't exist on the top left. Okay, it disappears. So in this demo, we learn how to rename a table in 2 ways. And we also learn how to delete it in two ways, in Management Studio and in Transact SQL. Okay, we have inserted data, we have data on the table, now we have to select them, and sometimes we can even filter the data. Okay, so we have the values we have created in this table, in this database. Now I want to select the values to see what's inside. Okay, selecting and extracting data is simply started with select. Okay, filtering the data will start with the where clause. Okay, the syntax is select asterisk from my table. Okay, select mean select the table. Asterisk mean all the column of the table. Okay, from. Okay, and the end my table. Okay, select asterisk from my table is the classic SQL command. The syntax of the where is placed just after the table name. Select asterisk from my table. Okay, where in this example first name equal Peter. Okay, we will see all this immediately in this demonstration concerning the set. Okay, let's go for the demo. Let's go for the select demonstration, the simple select as I showed you in the demonstration. Don't forget to use your database to work on the right database. Use formation, execute. Okay, it's good. We are in the good database formation. Okay, and I'm going to do a select. Okay, let's do a zoom. Just here the select. Okay, select asterisk from my table. Okay, the name of my table. I'm going to do a select. I select the line and run it. I have selected all the rows that were in the table. Here I took everything. The column last name, the column first name, nickname and first name. Okay? So with the asterisk, I took all the values of the table. Okay? What if I want to select just one column? I take one column here. First name. I'm going to do a select. Here the result for the first name column. Okay. First name here and first pair just here. I don't want the nickname. Okay, I only want the first name. Okay. And so we try first nickname. You must change this nick name. Let's select first nickname from person. Okay, and then we only have the nickname, the nickname names. Okay. What if I want to select both columns by their nickname and last name? It's the same thing that asterisk. Here the results are the same. Here you have the first nickname, just here, first name, is here, and nickname is just here. Okay? What if I reverse the names of the columns? I decided to have the first name in first and nickname just after. Okay, let's make the select. You see here that the select text takes the first column, first name here, and nickname just after. We inverted the column. Does it work if I remove the from? I do select first name, nickname, and here, if I make the select, it says that I have to specify which table invalid column name, first name and nickname. We continue, and the where I want, for example, the name Peter in my selection. Okay, I start again, select asterisk from my table. I take all the lines of my table and I want only Peter, just here. Okay, only the names that are Peter. I run the query, and here I have only Peter appearing. Okay? You see that the where is very interesting. Same if I just do a select from the nickname again, and I want just the name the king. Okay, I take here the name the king. Let's run the select, and here the result for the king. Okay, we have 3 rows. And is the column is in the where mandatory? Let's do a select asterisk from my table. Okay, and I remove the where just here. Okay, I don't put the where. Select asterisk from the table and without the where. Let's run the select, and we need the where. Okay, so here at this stage we insert the data and we select them, and now we are going to update them in the next demonstration. We have inserted the data, selected them, filtered them with the where clause. Now we are going to update data. Okay, updating data on SQL is launched with the simple update. The syntax of the update is update with the name of my table, update my table, set this new value on this column, set first name, set on this column the new value Elvis. Okay, we will see all this right away in a demonstration to make it clearer. Okay, let's go for the demonstration about the update in Transact SQL. I'm going to look at the data by doing a select from person. Let's execute this query. We will select the data. Normally you have these values on your table. Okay, we have Peter Pan, and King Lion and Lion 2. It's a mess. Okay, so I'm gonna to put some order and I'm gonna change the lion value here, okay, by the king Elvis. Okay, so I'm gonna change the first name column, okay, with this value, sorry, first name. So set first name like Elvis, where the nickname is the king. So we're gonna change these four values, because we have 4 rows for the kings. I put the where. If I don't put the where, it's gonna to update all the data in the first name column. Okay, I will show you right afterwards where that you must to put always a where when you do an update. Okay, so let's execute this query. 4 rows affected. It's perfect. So are we good? Let's make a new select and let's get a look on our fantastic job. Now we have the King Elvis for the 4 rows. Okay, the King Elvis 4 times. It's perfect. So we have changed 4 values in this example. So let's see the data that we want to update without the where. I want to put Candy in the last name, in the first name, sorry, column. But if I don't put the where, let's see what's happened. 5 rows, sorry, affected. Okay. And what does the select give us? Now we are not good. We have changed all the values we have in the first name column. Okay. We have put Candy everywhere in each rows. Okay. So when you do an update, it's imperative to put a where, because like that you centralize your data, you target them. If you don't put a where in the update, you're gonna change all the values of the column. Okay, as I showed you in the demonstration. So it's very important to put a where. It will filter the data in your update. Okay, understood? So I hope you have understood this little lesson about the update. Now we are going to move on the delete part. Let's go for the delete demonstration. So how to delete data on SQL Server. Okay, deleting that data on SQL is launched by a simple delete. Okay, the delete syntax is delete from my table. Okay, you can see that the syntax is almost identical to select. Okay, so the select is very similar to select. Okay, so delete from and the name of my table. Okay, you will see that in demonstration right away. Okay, so let's go for the demonstration of delete and where. I'm gonna to do a select from person, and and you can see that it's a mess. Okay, what we did, sorry, in the last update, admit it's not very professional. Okay, Peter Candy, the King Candy, it's a mess. Okay, so we are going to delete the King Candy. Okay, the row King Candy. So we're gonna remove 4 rows. Okay, let's get a look on the query. Delete from the name of my table, from person, where nickname equal the king. Okay, so let's execute this query, and we have 4 rows affected. That's not bad. I do select asterisk from person, and what does the select give? That's not bad. We have deleted all the data we want. Okay, so here we deleted the king, and if we did not put the where, okay, as in the date, what happens if I put delete from? I will show you right away. As in the date it's the catastrophe. There is nothing anymore. Okay, if I run the select, you have nothing. Okay, delete from the tables, delete the whole table. Okay, so you must put aware. You must filter your data like in the update when you do a delete. Be very aware of this because there can be catastrophic repercussion on your data if you don't control your data when you execute SQL queries. So here in this section we learn how to do a delete, an update, an insert, and a select. And this is frankly good. Commands and square bracket on SQL Server. As I told you in the previous demos, commands on SQL Server are notified by 2 dashes. Okay. If I write, for example, my name and run this query, could not find through procedure tuilier. Okay. SQL doesn't understand this kind of language. Okay, to put commands, small notification, you have to put 2 dashes. Okay, they are very useful to follow the evolution of the code that there can be in a view, in a query, in a function, to see how this code will live if you make modification on it. To see the modification that there are in time on this code. So it's very a good practice to command your code. You can command on each line. For example, I'm going to make a top 100, okay, on person, my table person. I can put get me the first 1000 lines where name égale, where nickname égale tuilier. It's very simple, but in some cases, when a new developer arrives and discovers this new code, for him, it's going to be a golden source to know the functional side of this code. You can also command it with SSMS. There is a little button up just here. Command how selected. the selected line. Okay. If I put my name and click on this button, the commands, my name is now command. Concerning the square brackets are also very useful when you create a column with space in it. For example, I will create a square bracket table with a column with space between each character. Like this one. Column with space, but with 2 square brackets. Okay, let's create this table. The problem with this is that when I select this table, if there are space, you cannot select that column. Okay? If I run this query, incorrect syntax near the keyword with. Okay? It doesn't work. You have to solve the solution to this problem is select with the square brackets. Okay? This one and this one. And if I'm running this select, it's good. There is no error syntax. It can be used also for terms reserved by SQL. We want to create a table. We absolutely want to put the name table in the name of these columns. Okay? This one. Let's running the create table. And we can see that we cannot do it because it's a word reserved for SQL Server. Okay? What we can do is to put a square bracket in the name column. Okay, let's just here the square bracket for the table column. Let's create the table. Sorry, there is already a table created. It's not a problem. I'm going to drop it. And create the table, it's good. Okay, no error on syntax. And if I do a select on this table with the square bracket, without the square bracket, it doesn't work. But if I add the 2 square bracket, okay, it's running good. Here also the square bracket is necessary. How to simply do an update on 2 columns. We are going to use, as always, the formation database, okay, and insert just true row for the demonstration. What does the select give? Just 2 rows. The king Elvis and the king lion. It's my friends. And if I want, for example, change, as we saw in the previous demonstration, the king, by the nickname Peter. Okay, nickname the king by Peter. It's just a simple edit. And what does the select give? It's perfect. Peter Elvis. Okay. But what if I want to do an update on 2 columns at the same times? If I want, for example, set my name, Tuilier Olivier, and replace Peter Elvis on the same script. Ever makes 2 updates. If you want these 2 updates, the first update set nickname. Sorry for the zoom. Nickname Tuilier, where first name. So we change in the first script nickname here, and in the second script we change Olivier in the first name. If we run these 2 scripts, what does the select give? It's perfect. Okay? But Imagine that we want to do an update on a table that has more 50 columns. It's going to be complicated. There is a trick. It's that we can put a comma to simplify the script. Okay? Let's delete insert row and select for the demonstration. And we are the king in this is coming back. And in this script you can see there is a comma. Let's make a zoom. Update person, set nickname, Trudy. So in this column, comma, first name Olivier for the first name column, where the first name is Elvis. So this data, okay, this row. If we are running this query, just one row affected, and what does the select give? It's perfect. Olivier. Okay, so we can see in this demonstration how to do a simple update on two columns with just one script. Okay, so let's go for the next demonstration. How to insert several identical values at once. I have a classic table that I'm going to create, and I'm going to insert a value one, for example. If I do a select from this table, select étoile from simple table, I have just one value. Okay? And if I want to insert the same value several times, 10 times, for example, I will have to copy and paste this quite 10 times, okay? Which can be extremely disturbing and time wasting. Okay, let's execute this insert, several one row affected. And if I do a select count for count the row number on our table, 11. Okay? And how to insert several identical values at once. There is a simple query to do this kind of manipulation. You have to do an insert into classic values 1, and you have to put go and 10 here. Okay, so here after the go we tell it to run this transaction 10 times. What happens if when I run this transaction, it's called an execution loop. Just here. Okay, one row affected, and if I redo a select count from my simple table, now we have 21 row on our table. You can see that it has inserted 10 value. So use the go with the number of rows you want to insert in your table. It will spare you from writing a script that can be very long. Don't forget this parry to insert the same value several times. Okay? So let's go to the next demonstration. Okay, focus on the three previous sessions. For the moment, we have a database. Okay? And we have a table with data in it. Okay, with Michael Jackson, Liz Taylor, Grace Kelly, all my friends are in this table. We also learned how to select data with the select, update data with the update, insert data with the insert, delete the data with the delete, and filter data with the where clause. Okay, and that's good for now. So what we are going to do next? We are going to do a little more Transact SQL to improve our queries. We're gonna see to that we can deepen our knowledge of Transact SQL by adding a lot of clauses like and, and or, the light, the distinct, select into, order by, and so on. Okay? So let's go together to the next section. Demonstration about varchar and char. Character can be inserted in the columns of type char, varchar, and text. Okay? Forget the text here because it will disappear in future SQL version. When you see type of columns on the table on SQL, you will see char and varchar most of the time. The difference between char and varchar is that char has a fixed length while varchar has a variable length. Okay? If we declare a column in char 10, for example, it won't be able to exceed 10 characters. Okay? If we put 11 characters, it won't work. On the other hand, if the text size varies a lot of, or if the data length can be large, you should go for varchar. Okay? The maximum size of varchar is 8,000 characters. You can't put more. For example, we will opt more on char1 to give the gender of the person, male or female. There is no point in putting a varchar on a column where there is just male or female. Okay, you understand? For the syntax, we have already seen it while creating a table. Create a table with the varchar 2000 and the char1 just there. If I put here just 10, I have a column. I will have a column with a maximum of 10 characters. It cannot be exceeded. Okay, let's go for the demonstration. Let's create a table type column and insert just one single row with the char just there. And what's going to happen? Insert. We have an error message. Where SQL Server, the string or binary data will be truncated. Try to insert and so on. Okay? That's why he could not insert all the four characters for char into a column with the char1. Okay? I will try a new request again and just here insert a C. Just try. It works. Okay, there is no error message. If I run no select, I have just a C here. Okay? And if I try, for example, C8, I have the same message here. String or binary data will be truncated in table and so on. Okay, can we insert numbers in a char or varchar column? I insert a simple value with just 1 and 2 into the varchar or char or varchar column. And if I run this query, it works. and the select just 1 and 2. Okay? SQL interprets numbers as a string. A colon in char or varchar, we accept all letters, and colon also accept number. As I explained before in the presentation, a char or varchar colon can only have a maximum of 8,000 characters. If I create a table with a char 8001, and I run this query, I have a error message. The size 8008 given to the colon chartest, except the maximum allowed for any data type 8000. And if I try with 8000, it works. You will see from time to time the character n in front of char and varchar. So columns will become in nchar or varchar in some table. Okay? For example, it's my name in Chinese, Olivier. Okay? And if I do a simple select with the Chinese characters, that mean Olivier, SQL Server, SQL, can't interpret it. The data engine treats the string as Unicode. And if I had just n just before here and run the select, SQL can interpret this string in Chinese. So here have a big difference between char and varchar and between varchar and varchar. So keep in mind this big difference. A varchar colon is a colon that will vary in the string level, and a char colon is a fixed colon that cannot move. Okay, so let's go for the next demonstration. Let's go for the demonstration about int, begin, small int, and tinit. The tinit accepts a row from 0 to 255 bytes. The small int, which goes from 32,768 minus and to 32,767. Okay. The int goes from 2 billion minus 2 billion to 2 billion and more, and begin that goes from I will let you win the number minus a very large number. Okay. Use solution as usual, and let's create a table numeric with 4 columns. 1 column in init, 1 column in small int, the third column in int, and the last column in big int. Okay? So let's create this table. It's done. First, we try to insert one value with 256. Okay, for the column tinit. If I run the query, I have a error message. Arithmetic overflow error for data type tinit value 256. So we cannot insert a value of 256 because the maximum value in a tinit is 255. Okay? And now what if we try 25? It works. And what does the select give? It's okay. Okay? 255. Another question, can I insert a letter, a character in an int column? if I try to insert the A character, okay, normally for the varchar column, but here it's a tinit column. And if I try to do an insert, conversion failed when converting the varchar value A to data type tinit. So you can insert number because they are considered as a string, but you can insert character or other types of character apart from numbers, okay? Don't forget to put the cut for string, but for numbers you don't need them, okay? As soon as you have a numeric type colon, you don't need to put cut, okay? But for characters, it's mandatory. Let's continue. Can we insert negative values in the tinit? For example, -1 here for a tinit colon. And if I try to run this query, value 1, I have an error message for the value -1. Okay? And can we insert negative values in the small int? For example, here -5 for a small int column. It works. We can see that the small int accepts negative values. Okay? Last test, last question. Can I put comma in the columns? Let's try with the 0, 1, just here. Okay? Insert. And we have another error message. Conversion failed when converting the varchar value 0, 1 to data type tinit. For this kind of character with a comma, you have to create a decimal or float type column. Okay? These are not very frequent cases. Okay, so let's go for the next section. Let's go for the data type column. We are going to deal with the following type of column for dates. Date, small date time, and date time 2. Small date time takes rows value from 1 January 1900, okay, to 6 June 2079. The date time goes from 1 January 1753 to 31 December 9999. Date time 2, I call it date time 2 because it will replace the date time on SQL Server. It goes from 1 January 0001 to 31 December 9999. Okay? So you use the formation database as usual, and I will create a new table like table numeric with a date. One column with date, one column with small date time, and the another columns with date time and date time too. And let's just insert one row with get date. Wait, Olivier, what is the get date? The get date simply gives you the day's date. Sorry. If I run select get date, today it's the 7th January and this year 2021. And if I want the yesterday date, it's, I think you understand, the 6th January 2021. Okay? That's the explanation for the get date. So let's insert a single value. Sorry, I forget to create the table before. Let's insert just one value, and if I want to select, here I have something interesting. The values are not the same. I'm going to go first to the date column. Here I have just the date. Okay, I go to the small date type. If here I have the value of the date plus the time. Then I go to the date time column. Here I have the date, okay, and the time, and the milliseconds, okay. Finally, I have the date time too, that will replace the date time. I have the date, I have the time, and the milliseconds that are more precise, okay. To recap, the date column takes only the time. The small date time columns has a precision of 1 minute, so it always takes 1 minute more. If, for example, the time is 9 p.m. 36, it will take 9 p.m. 37. Okay? The date time and date time columns support milliseconds, except that there is more precision in date time. Okay? So it was a small demonstration of the date column. If you create new tables, go to date time too instead. Okay? So let's go for the next demonstration. Okay, this is the demonstration to add, modify, delete, and rename a column in SQL Server. So let's create a simple table column modification here. Okay, the table has been created, and if we get a look on the left side in Management Studio, our table is just there. Okay, column modification. Adding a column in Transact SQL is simple. Alter table with the name of my table and add column, the name of the column I want to add, and the type of column, varchar 20. Okay, let's run the query, and if I refresh my table, I have now two columns, column 1 and column 2. Okay? And if you want to rename the name of the column with SP rename stored procedure. Okay? SP rename the name of my table with the column that you want to rename with the new name that we give us. So column 3, okay, and the column, not table, like as we seen when we rename the table, but here is the column. And if I run the query and refresh on Management Studio, you can see that the column 2 is now the column 3. Personally, I find it very complicated to rename just a simple column using this command. You can just do a right click, rename, and put 4. You can see that it's simpler with Management Studio. Okay? So I advise you to do in Management Studio. And what if you want to change the type of the column? If, for example, I want to change the column 3 with charges. Okay? So it's not a good column. I change it right now. So my column is in varchar 20, and I want to change it to charge 10, sorry. So the syntax is alter table, the name of my table, alter column, the name of the column, and the new type of column I want to give it. My column 3 doesn't exist. I make now column 4, and if I run the query and do a refresh on Management Studio with F5, you can see that now the column 4 is now a char 10. Okay? And to finish, if you want to delete a column, alter table, like drop table, drop database, for the column, it's drop column, and the column that you want to delete. Let's run this query, and if I refresh the table with the column, you have just now the column 1. Okay? So in this demonstration, you have seen how to add, modify, delete, and rename a column on your table. Okay? So let's go for the next demonstration. Okay, here we go. Now we learn to deepen how to transact SQL. We learned how to select data, update them, insert them. We played with the where filter, and we also learned how to delete data. And now we are going to go further in transact SQL, and we gonna to deepen how knowledge about the transact SQL. Okay, so we will go step by step, and first of all we gonna see the alias in the columns. So how do the alias works? It's pretty simple. You have to know that we can rename a column in the select by an alias using the has clause. Okay? So let's go. Don't forget to use your database formation as always. And we are going to create a table that we are going to work with the rest of the course. Deepening in the transact SQL will be done on the contact table. Don't be afraid, the table where I will insert multiple values is attached in the course. So you won't have to retype the whole lines in this script. Okay? All my friend is here. Michael Jackson, Bruce Willis, Marilyn Monroe, Angelina Jolie, and me. Je suis Olivier, Sharon Stone, and so on. Okay, let's execute the create table and insert all the data. Okay, 50 rows affected. And what does the select give? Select asterisk from contact. We have got all the lines, the 15 rows. Okay. Now we are good. So we are going to work with this table until the end of the transact SQL course. First, we are talking about the alias of the column. So select, let's make a zoom, select name as, with the alias as, nickname from table. Okay, let's call our column name as nickname. Okay, the syntax, as you can see, is very simple. Okay, so let's execute this query, and you can see that the column name just there has been changed to nickname. Okay, so can I rename all the columns? Of course you can. So let's make a zoom. So in this example, select name as nickname, first name as Superman, age as Spiderman, gender as Batman, okay? And date of birth as Hulk. If I run this query, you can see that all the columns have been changed. Nickname, Superman, Spiderman, Batman, and Hulk, okay? Hulk in French. Okay, so you can see that's pretty simple to put the alias in a query on Transact SQL. So that's it. That was the alias of columns part, and we go to the next section. The like. We are going to talk about the like because it's a very interesting function because it allows us to refine the filter search that we can have with the where. So we can, with the where, assign a like to it. Okay. The syntax of the like. I want, for example, to search in the name column all the names where there is the letter O. Okay. If we put where equal O, if there are no values equal to O, the where won't give us anything. Okay. But with the like, if we do select as a name from contact where name like % or %, here this specificity will allow it to search in the name column that has the row. Okay, %O % will search in all rows of the entire name column, all names that have the row. Okay. It's a special request, but you can do it with the like. So what does the like give? You see here in the contact table that all these names have the letter O, sorry. Okay, all names with the letter O. It can be interesting in some cases. There are a lot of other specificities on the like. Okay, we will see in the demonstration right now. Let's go for the like. We're gonna select, do a select on the contact table. We have 15 values that are in the table. Okay, 15. As I'll show you in the previous demo for the table contact. The like, first of all, can work as a where. Okay, you can see here the first select with the equal, where name equal DiCaprio, and just below select a name from contact where name like DiCaprio. Okay, and if we take both values, it's the same result for these two queries. Okay, DiCaprio and DiCaprio. So we can replace the equal by a like. Okay, but with the like we can do much more interesting things. Let me show you an example. If, for example, I want all the age that start with a 2, you see this syntax. I put 2 and just after the 2 the percent. Okay, let's execute this query. You see here the age with 23, 22, 22, 22, 28 and 22. What if I don't put the like and I put unequal instead? We replace the like with 2. There is nothing. We don't have in our color an edge that corresponds to 2. Okay? That's the difference between the like and the equal. Contrary case, if I want the age ending with 2, instead of putting the percentage after, we will put it the percent before. And we have 4 results: 22, 22, 22, and 22. So that's the difference between the percent after 2 and percent before. Okay? In this case is all the age ending at 2 with the percent just before 2, and with this example the percent after the 2 it's for the age that start with 2. Okay? What if I want all the names that have the letter I in them? Okay? So in this example, as I show you in the demo, when you put 2% in the string following by the quote, it will take all the values where there is the letter I in the column. Okay, I'm going to play this query, and you can see that there are 7 persons in my table that are the I in the name, the column name. Willis, DiCaprio, Pete, Jolie, and so on. Okay? So as you can see, it's very an interesting function. It really allows you to refine new search contrary to the web. Okay. Next example. Sorry, if I want to find the names with the letter N. Let's execute this query, and we have 4 results: Jackson, Clooney, Monroe, and Stone. You can see that it works very well. And what if I want all the days, all the date of birth where there is 08? So there. Okay, select strings from contact where date of birth like 0%, 0.8%. Let's execute this query, and we can see there are 9 results with 0.8, 0.8, 0.8, and so on. So it works very well. For information, if we put brackets, you can take several values that look similar. When we put 2 strings in the bracket, okay, I'm going to show you the result to make it easier for you. You see I have in the name column Tuillier and Juillet, just here, Juillet and Juillet. Just the T and C that change. Okay, I put here T and C. It means take T and C followed by Juillet. Okay, so you see SQL is smarter with the like function. It took those 2 characters and found Tuillier and Juillet in the result. Okay, Tuillier and Juillet. you will rarely see but it was just to show you that it's possible to refine your search for a specific request like this one. So there you are. Those were the specifics of the like. It's much more powerful than the where, okay? And it will allow you to refine your research. Come on, let's go to the next session. The top returns the first set of lines that will be sent by the query. So if I do select top 1 from my table, it will return the first line of the query. Okay, the top can be very handy. It's pretty simple to set up. Just top with parentheses 1, top 100, 1000, as whatever you want. It's up to you. It can be also very good for bringing back a certain number of rows. Or, for example, if you have a table that have, for example, 22 million rows, if you do select asterisk from, the performance is going to be catastrophic, because bringing back to 22 million rows is going to be complicated. And if you only need the first 5 rows of these 22 million rows, a select top 5 will do just fine. You understand? Okay, as usual, I use the same database, use formation. Okay, what does the select give? Always the same 50 lines, what we inserted previously. Okay, Willis, Bruce, and Michael Jackson. So I want to just to select the first line of my contact table. Okay, let's type the query, select with the top parentheses 1. I close the parentheses. Okay, asterisk from contact. Okay, it's quite simple to write. It's quite easy. Let's execute this query, and you can see that Michael Jackson is the first line of my query, of my table, sorry. And what if I want to select the first 5 lines? Okay, copy and paste the same query and replace 1 by 5. Execute this query, and I have the first line of the contact table. Sorry for the zoom. 1, 2, 3. Okay, just the first 5 lines, 5 rows. For information, I can also use the top in the edit and delete. Okay. For example, I'm going to create a table box. Okay, box with chocolate. I love chocolate. Box with chocolate, and insert 3 values, the same value, milk, milk, and milk, in the box with the name of the column chocolate. If I make a select from box, sorry, I have to create the table before. We have 3 milk. Okay. So if I want to delete the first line, the syntax is very simple. Delete top 1 from box. You can see it's very simple to write. Let's execute the delete. 1 row affected, and what does the select give? Just 2 rows. Okay. So the top also adapt to delete. We can also adapt it to the update. We can update the first line of the table. Update top 1, set chocolate equal coffee. Okay, update top 1. Let's execute this query. One row affected, and what does the select give? Now for the first line we have coffee. Okay, so the top clause adapts to update, delete and select. It was the demonstration about the top on Transact SQL. So let's go to the next session. The distinct allows to remove duplicated value in my column. So let's go for the distinct demo. First, we do a select. We still have our 15 rows, 50 lines. Okay, one and Willis, Jackson and Willis, my old friends. If we look carefully, we have two Willis values in my table. Let's make a zoom again. Willis in the 5 rows, and at the 15 rows we have the second Willis. Okay. If we are running this query, I have two Willis. And if I want to remove these duplicates, I will do a distinct. Okay, let's make a zoom. It's simply to write select distinct with the name of my column, distinct name, and so on from contact where name equals Willis. Okay, let's execute this query. Now we have just Willis, only Harper's horns. Okay, I put the where, but behind to show you that the duplicate I remove it and only one value remains. I can just appear once. Okay, and the second Willis on this column disappear. Okay. So keep in mind that the distinct is for removing duplicates. Okay, how to copy a table? We can on SQL Server copy a table to save it. In case it make big change on my main table, I tell myself for security I can copy the table and save it. To copy a table to SQL Server, use the command select into. Okay, allez. So let's go for the demo, use formation, and we will start a select first. We have, as usual, we see that we have our 15 rows. So how can I copy my table? So let's make a zoom. Select asterisk into contact to from my main table. Okay. So let's execute this query. 15 rows affected. And if we do a refresh on the top left, refresh, we have a table contact 2. Okay. We see that we copied the data from the contact table to the contact 2 table. And if I do a select on the contact 2, it's the copy of the table contact. Okay, is the same rows, 15. We see that all the columns are identical to the principal column from contact table. Okay? And what if I want to copy just one column? One column, it's select name, just the column name, into the new table to create for the copy, contact 3, from my main table, contact. Okay, execute this query. 15 rows affected again, and if I do a refresh on the left, we have a contact 3 table which appears. And what does the select of the contact table 3 give? Just the column name. Okay? And what if I want to copy just some data? If you have, for example, a table with that has 22 million rows, we can filter the data with the where, okay, and copy just some data. Is this? I do select into my new table, contact 4, from my main table, contact, where the first name equal Michael. Let's execute this query. Just one row affected. Okay, and if I do a refresh on the left, we can see the contact 4 is just here, there, and what does the select give for my contact 4? Just one row. Okay, we can see that just one row has been copied from my main table, my table contact, into the contact 4 table. So keep in mind that you can save your table before to make change on it. Okay, with the select into command. So let's go to the next section. Comparison operator. Comparison operator, it's something you will see very often in your SQL queries. Okay, we already use one of them. It's the equal. The equal, the one you use for the one. There are a lot of comparison operators. There is lower, less than or equal to, greater, greater or equal, and different. So you see that there are two ways to write different. The first one is the one we use the most often. Okay, so come on, let's see this in a demo right now. Okay, let's go for the demonstration about the comparison operators. Let's run the select again to see my data. That always goes to Michael Jackson to Bruce Willis. Okay, we have our 15 rows. First question, I want to select just people who are less than under 20 years old. We are not going to focus more on this column anymore. I don't want to take only young people. I want to select people who are under 20 years old. Okay, so let's make a zoom. I select from my table where age under 22. Okay. Now what does this query give me? I have 3 people who are under 22. 18, 16, and 17. Then I want to select the age of the contact that is equal or less than 20 years old. Select from contact where age, under, and equal. Here the query take out 18, 16, 17, but also those who are 22, that the specificity are under and equal. Okay? Next, I want to select the age of the contact who are over 34 years old. Okay? Same, and let's execute this query with over 34. Here I have 5 person, 37, and so on. Okay, 40, 48, 41. Okay, I want to select the age of the contact who are more than or equal to 34 years old. Okay, same. It will be equal, over, or equal. Okay, over or equal. The equal must be under the over sign. If I put it behind it, and let's run this query, it doesn't work. Incorrect syntax. Okay, it just behind it. After it, sorry. Okay, and let's execute this query. We have 6 rows with the 34 years old. Okay, equal, over, or equal for Sharon Stone. Okay, I want to select the age of the contact that are different from 41 years old. I want to take all of them. Let's execute this query, and we can see the sign of different. Okay, and if I run this query, so you can see here that those who are 31 years old do not appear, just here. Okay, it doesn't appear. And if I run a query with the age, the person who are 41 years old, we have 2 persons. Okay, Juillet and Tuillier. Okay, so there are many people who are 31 years old in my table. It can also be written in a different way, which I see very rarely. This one, it corresponds to different form. And if I'm running these 2 queries in the same time, 26 rows on the bottom right. Okay, but if you want to see the number of rows it returns on the 2 different columns, 2 different windows, so you have to click on the first row, and if you get a look on the bottom right, you have 13 rows. Okay, so here we are, 13 rows for the 2 queries. If you click on the 2 different column windows, we have 13 rows. We can unfold the windows. Okay, we can see there is Michael Jackson on the first and second query, and at the end it's Bruce Willis, 13 rows. So we have on both queries all the edges that are different from 41 years old. Okay, it's exactly the same thing. Okay, in this demonstration, I hope you have learned more about the comparison operators, and we will continue on the next section. The in and not in determine whether or not a specified value matches a value in a list. We will see the syntax for the not in. Select from my table contact where name not in bit. The where not in bit will not take the value bit in my query. Okay, but if I put select from my table contact where name in bit, it will take the value bit in my query. That's the difference between in and not in. We will see also is and is not null. Okay, they are used to select null values or not. Null correspond to a value that is nothing. It's a kind of marker on SQL that specifies that the value is null. Okay, that there are no value in this column. So null and not null is a query that will be used very often on Transact SQL. You also have a lot of tables that we have null or not null values. The syntax is select from my table. Okay, so here I say to my my date of birth colon, you going to get me the values that are not null. To remove the not, just put is null. Okay, at the end, to look for null's value in the date of birth column. To make it clearer, let's see all in the demonstration. Okay, demo. Int, not in, is, and is not. We'll use our database formation as usual, use formation. We will remember the values we have in the contact table. We have 15 rows as usual with Michael Jackson and Bruce Willis. And if I want, for example, just the name clone in my query. Let's make a zoom. The name clone. We can do select for my name, my table contact, where name in with parentheses, cut, clone, parentheses, and cut and another parentheses to close in. Okay? Let's play this query and just clone George. Okay? The equal and the in are the same. Okay? We can change this query and type clone with a cut. It's better. We have the same result. Okay? But we will see that the in has other specificity right after. And if I want only want woman in my request, we will then use the not in. Let's execute this query, and here I have only women who appear in my query, gender female. Okay, not in, and we have only just the female gender who's appear in my query. Not in means that I don't want to take this value. So, as I told you before, you can put several values in the in. Okay, if I put the in or the not in. So in this example, don't take me the values Stone and with the comma and DiCaprio. Okay? So don't get me this value. Okay, I don't want this value in my query. If I run this query, I have only, for the zone, 30 rows. Normally we have 15 rows. Now we have 13 rows in my query. Okay? And if I change the not in by the in, the two rows with the in stones and DiCaprio, which appear here, DiCaprio and stone with the value, with the clause in. The null. As I explained in demonstration just before, SQL considers that the null value represents nothing. It's a kind of marker that will say that if this field is not filled in. Okay? So we will insert a new line. In this line, we're going to insert this value, Portman Natalie. Okay? With 25 years old and female, but we specify the null value here for the date of birth. Okay? So the last value of this row will be null. There is no value entered for the date of birth for Portman Natalie. Okay, one row of 18. And what does the select give for Portman? You can see that date of birth is null. So in my query, I want date of birth that not null. That's to say, filled in. Okay? So my request, my query will be select from my table where date of birth is not null. Okay? It's quite simply to write, and you can see that the values Portman Natalie is not appears. Always 15 rows. And if we want the date of birth which are not filled in, select from the tab where date of birth is null. Okay? So I want to see where the null value has filled in. So in my query, now I have Natalie Portman, which have the date of birth, is null. Okay? So you can see that the syntax is not very difficult to memorize. So there you go. It was about these 4 little operators that you will often see in Transact SQL. In, not in, is, and is not null. Okay? Come on, let's go to the exercise. And or. And or are 2 logical operators that you will see very often on SQL. So this was an opportunity to talk about them. First, we are going to see the AND. What does the AND do? The AND operator allows you to join several conditions in a query. It applies to the where filter. The AND clause requires both conditions to be met to return the query. Okay? Let's see this in the syntax. Select from my table contact where month, date of birth equal 08 and age greater than 16. Okay? So I select people who were born in
August and also those who are over 16 years old. If one of the conditions is not respected, if for example age greater 16, the query doesn't return anything because one of the conditions of the query is not respected. Okay? Anyway, we will see all this in the demonstration afterwards. The OR is a bit similar to the AND, except that it requires only one condition to be met to return the query. It also applies to the where filter. The syntax is select from my table where name equal Monroe or name equal Eastwood. Okay? So take the name the person who has the name Monroe or the name equal Eastwood. Okay? But if my first condition, Monroe, does not meet my search criteria, I can take the name Eastwood in my query. Okay? So to make it clearer, let's see all this in demonstration right away. So let's go for the demo and then OR. I do a select from my contact table and I have always my 16 rows in my table. Okay? Michael Jackson and Natalie Portman. Okay, we will start with the end. At the beginning, I want to select the men who are less than 41 years old. Okay? So let's get a look on my query, where gender equal male and age under 41 years old. Okay? So let's execute this query. Now you can see that it works perfectly. So I took only male sex and with persons under 41 years old. Okay? In my another query, I want people born in August who are over 16 years of age. Okay? Where month that date of birth equal 08 for the August month and age greater than 16. Let's execute this query. This also works perfectly. Okay, no problem with our two queries. So I told you in the demonstration, the AND clause requires both conditions to be met in order to return this query. Here we take the same query, but I put age equal 101, for example. Okay? Just here, age 101. The value 101 does not exist in my column. So here I take the month of birth August and also the condition age 101. Will it work? Here we see that it's interesting because there is a condition that is not respected despite the fact that there are people who were born in August, the second clause. People born in August exist, but there is not an age 101. So the end condition is not respected. The request doesn't return anything. Okay, you understand? The OR, on the other hand, only requires that one condition be met. If I play the same query that is here by replacing the end with her. Here I replace and with her. So I have a condition that is good. However, age equal 101 is not valid. Let's play the query. Here we see that the query returns people who were born in August. Okay? It didn't take into consideration the age that is equal to 101, but it took into consideration the condition that is valid, the condition of August. Okay? This is the main difference between and here. And if I take the people who were born in the month of August and are 16 years old, okay, in this query, we will see an interesting case. There, both conditions will be met. The date of birth and the age greater than 16. Okay? So, let's execute this query. Here we have an interesting case. The query took out all the rows, all the line. Why? Because it has cumulated both conditions. All those who were born in August and all those who are over 16 years old. Okay? So, people who were born in August and also those who are over 16 years old. In fact, the two conditions were met, so it has cumulated the two results together because it has also taken the people who were not born in August. Okay? This is the difference between the and the or. In the or, if you set several conditions, it takes out all the row, all the line that are in this condition. Okay? The and we filter and we'll see if both conditions are met. Let's get a look on the another query. If I want, for example, the name of Eastwood and Monroe in the same query. Select. The query result, nothing. It doesn't work because the and cannot be applied on the same column. We will then leave on the or. If I change and by the or, let's execute this query. Now we have the good result. Eastwood and Clint. Okay? So there you go. I hope you have learned more about and or, and we will see them in the exercise that I'm going to give you later, so that you can practice on these two clauses that are a bit special, but you will see very frequently in your SQL query. Okay? So let's go on the next section. The order by. The order by allows to sort the row in the result of a SQL query. Okay? It's possible to sort the data on one or more columns in ascending or descending order. The order by simply sort the data. Okay? So let's go for demo. Use formation as always. And what does the select give? And we will work on the age column first. Okay, we have always the 16 rows in the table contact. Okay, we are going to work on the age column. So I'm gonna sort the age from the youngest to the oldest. So in this example, I will do. order by age, okay, with descending sort. And what does the select give? Here I have a sort on the age column, here, from the youngest to the oldest. It starts with 16 years and end at 48 years old. Okay? And what if I want to do the opposite, from the oldest to the youngest? So we change ask with desk. Okay? So let's build this query. Here the reverse has happened. Okay? The column starts with 48 and ends with 16. Okay? Sorting can also be done on the other types of column, not only those with numbers. We can do it on the character types of column too. You can, for example, make an order by name without specifying the ask or desk at the end of the order by. Okay? Order by name. For the moment, no, we not specify the ask or desk. Okay, let's execute the query. And you see I will order my data according to the name in the column B, C. So here we have sort data according to the name in the column, and it's end up at W. Okay, Willis, my friend. And what if I want to sort but by the year of the date of birth? Let's remove the desk and let's execute this query. So here we see that we have sorted from the youngest to the oldest. Okay, and there you can see that by default, if we don't put ask or desk at the end of the order by, we can see that ask applies, the ascending applies automatically. Okay, it's important to notice. Ascending applies automatically. Okay, with or without the ascending, we get the same result. So ascending is the default sort given by SQL when we put an order by, but without specifying at the end how we want to sort the sort to be. Sorry. Okay, and what if I try desk? And now we start from the youngest to the oldest. Sorry for the zoom. To the youngest to the oldest. Okay. You can see that it works very well. It works birth way. And what if we try the month? We replace the year by month. I want the month from the first one to the last. Okay? So let's execute with the desk and the month. So it's not the good query. Let's execute the query for the month, order by month desk, and we start at the oldest month. Okay, August. Okay, here it goes from August to January and August. It works very well. So we see that the order by is a powerful function at the level of sorting. We don't sort just numeric values, we can also sort on date of birth, on name, and on character string. Okay, so let's go to the next section. Min, max, and average. Min simply returns the minimum value of a column. Max, as opposite, to min returns the maximum value of a column. Average returns the average value of the values in a column. So first of all, I'm gonna to do a select from contact order by edge. Okay. Use formation and let's run the select. In the edge column, you go from to 16, sorry, here to 48, okay, years old. So I will select the minimum age in the age column of the contact table. We've got normally the 16 for Liz Taylor. The syntax is very simple, minimum with the two parentheses with the name of the column from contact. Okay? So let's execute this query. So it's good. It plays its role well. Okay? And if I want to select the maximum age in the column, select max with the name of the column, age, with two parentheses, from my table. Let's execute this query, and we have 48. Okay? So it's the highest age. So it's the max. And what if I want the average age of this column? Okay, so we replace max by average. It's the same syntax. Okay? And the average of this column is 28. Okay? It made an average of all the age, which gave an average of 28 years old. Okay? And if I want to select the minimum age of people who were born in 1976. Okay? So select minimum age from contact, where year, date of birth equal 1976. Let's execute this query. Here it tells me 18 years old. We will check by ourselves to be sure. I do a select and we see that the minimum age is 18 years old. For the moment, it's not mistaken. A rather eccentric request. I want the maximum age of all people who start with the letter here. Okay, so I replace it, it's not a good column. Select max age from contact, where first name, like he. Okay, and the percent. A like can also be associated with the max. I want the max of the age of all people who start with the letter E. So let's read this query. The result is if I change the percent, I'm just before the E, we have 25. Okay? We will check it again ourselves to be sure. And the max is 25. Okay, is the max of the edge corresponding to this column. Can we apply this to a column where there are characters, like the name column, for example? Okay, so let's make a zoom. Select max with the name of the column from contact. Okay, let's execute this query, and it's Willis, okay, which is of the character type, as you can see, that is correspond to the letter W. SQL has sort them in alphabetical order and has taken the last name with W, so Willis. And what if we take the minimum? Select min, we replace the max by the min, and it's juillet. Okay, logically it will take juillet because it's the first letter in the alphabetical order of the column. Okay, so it respected the alphabetical order. It took the first line that starts with C. Okay, these are the major difference between min, max, and average. These are functions that you will see very, very frequently in your SQL query. Okay, so let's go for the next demo.
Sum and count. What does sum do? The sum aggregation function allows to calculate, like min and max, the total sum of the column containing just numeric values. Okay? The count will count all the rows of the column for all types of columns. It also takes the column of character types, char, varchar, and so on. And it also counts the numeric column. Okay? So first example, select count me the number of lines of rows in the contact table. So select count asterisk with parentheses from contact. Okay? Let's execute this query, and we have in the table 16 rows. Okay? We select count, we count all the lines in the table. So is it good? It's good because we have 16 rows in our table with Natalie Portman. Okay? What if I put a column name in the count? So we can add a column inside the parentheses. In this example, it's name. Okay? Select count name from contact. We have 16 rows. The name, it doesn't change. You can also filter. Why don't we count the rows that don't have null values? Okay, so in this example, select count asterisk from my table where date of birth is not null. And in this query, in this example, now we have 15 rows because we have just one row with a null value. You can also add a distinct to the count. Okay? For example, if I do select from a contact order by first name, we have Olive with a duplicate and both. Okay? So I have a duplicate values. I have 2 Olivier and 2 both in my table. So the query is select count distinct. You had the distinct
into the parentheses with the column name to distinct. Okay? So, what does the select give? 14. Okay? Logically, it will return 40 rows to me because I have 16 rows less 2 duplicate equal 14. The account is good. So we move to the sum. So first example, can I do a sum, an asterisk into its parentheses? Can I put an asterisk? It's impossible. Incorrect syntax near the asterisk. Okay, the star. Okay, and the name column. If we add the name column, the sum, name column, sum name from contact. It doesn't work. The operand data type varchar is invalid for sum operator. We cannot do a sum on the character column, but the count can do it. Okay? Sum works only on numeric columns. And on the edge column, it's work. It made the sum of all the edge in the contact table. Okay? So the sum is 463. I do a select to better understand. It made the sum all this edge, 18, 16, and so on. Okay, and the sum in 463. We can get around the count problem if we do a sum 1. What is the sum going to do? It's going to calculate the number of rows in the contact table. It's going to add up all the columns in the contact table. There are 16 rows there. We can do a sum 1. If we do a sum 2, logically, it gives me 32 rows and so on. Okay? We can also calculate the total age of woman in the query. Select sum with the age from contact where gender equal female. Okay? So execute this query and we have 157 years. Okay, so this is the main difference between sum and count. You will see them very often in your SQL query. So you have to understand that count means to count and sum means the total. Okay, so let's go for the next session. Between is used in an SQL query to select a range of data in a query using the where. Okay? The syntax is select from my table where age between a value and another value and with the order by, but it's not mandatory to put the order by at the end of the query. Okay? So don't forget between and a range of value. The between is always associated with the end. So first example, let's select the age between 16 and 32. Let's run this query. And what does it tell me? It tells me that I took the people between 16 and 33 years old and I ordered them well between 16 and 28 years old. It stopped at 28. Okay, you can see that it works but it works well. The following example, let's take those who were born between 1976 and 1983. Okay, let's run this query. You can see here the same syntax between these two values. Okay, let's run this query. You can see that it has taken the data interval that there was between 1976 and 1983. Okay, it's working. It's work very good. And with OR, does it work with OR? I've got the hand. Why don't I put a OR instead of putting a hand? And I will take the same example between OR and these two values. So I have the incorrect syntax near the keyword OR. Okay, the OR is not compatible with the between. On the other hand, it works very well with the not. You can put the not between. Okay, just here, not between, and these two values with the order by. So in this example, I don't want there to be no intervals between these data. To make it clearer, I will show you. Here, it took me everything that is not included between 1976 and 1983. Okay, I did a sort on the date of birth column, and here you can see that it took 68, 70, 72, 75, and 87. Okay, here it took everything that is not including between 76 and 83. Hence, the not betweens it means. Okay, I don't want the data that's between these two values. Okay, it was the demonstration about the between. So let's go to the next section. Group by. Group by is the act of grouping data together. Okay, the group by command it's used to group several results. Group by will always be called when you take several columns preceded by an aggregation function. Okay, so let's go for the demonstration of the group by. Use formation as always. And what does the select give? For my table contact, we still have 16 rows. Okay, Jackson and Portman Natalie. I have a request. Olivier, can you count me the number of people who are male in the contact table? Have you seen before, we are going to count the number of rows in the contact table where the people are male. So far, nothing very difficult. Select count. Okay, sorry, select count as total from contact where gender equal 1. And if I run this query, I have 10 person. Okay, they come back to me and tell me, Olivier, it's great what you have done, it's very great, but on the other hand, I want people who were born in 1976. Okay, what I do, I take the same request, okay, and I'm going to count the number of rows of people who are with gender male and who were born, and year, who were born in 1976. Okay? So I do a select, run this query as usual. So there is a little problem here. Colon contact gender is invalid in the select list because it's not contained in an aggregate function or the group by clause. So what does SQL want? What you should understand is that it wants to aggregate the data. It's normal because it will return a row, one row, and we call two columns. So we have to group the data to return just a single row. Okay? So the grouping of this data will be done under the gender colon and the date of birth colon. Okay? If we don't have the group by, we cannot group the data because we call an aggregation function here, the count here. Okay? The count is obliged to group the data in order to output its query. Okay? So we take the same query as here and exactly the add this one. There we're good. What I'm going to do, I'm going to add the group by with gender and the date of birth that it's called here. So let's execute this query. It works perfectly. Okay, here I have two people who are males and who were born in 1976. Okay, by grouping the data together, it works perfectly. We can check by this query, select from my table where gender equal male and year with 1976. Here we have the total number. Okay, we have two rows directly. Okay? So this is the function of group by. We group the data. When you have an aggregation function, count, sum, that use several columns, we have to group the data together to output the query. Okay? I say group many times. It's to get it into your mind. You have to group the data. Okay? So come on, let's stop talking about the grouping and move on the next section. The having condition in SQL is similar to where, except that having allow filtering using the sum, count, average, min, and max function. You cannot put an aggregate function in a where. Okay? It doesn't work on SQL Server. So I have a question. Olivier, count the number of people who are male and who are between 20 and 25 years old. Okay? Given the previous section, you know how to do it. I will count, select count, and with the group by. Okay. So let's run this query. If you follow in my last section, now you can do it this query without any problem. So I have two rows. Okay. 4 people with the age of 22, male, and 1 person with the age of 23. Okay? Okay, Olivier, but now I want the total greater than 2. So I want to have just the 4 and not the 1. Okay? I want total greater than 2. So let's try with the sum. It's the same query, but we had the sum greater 2. Okay? Group by gender and age. Let's run this query. We see that we have an error message. Invalid column name sum. We cannot put an aggregate function after the where. And sum greater than 2 after the where, it doesn't exist. Okay, it doesn't recognize it. So the where cannot take an aggregate function like the sum, as I explained to you, but having does. I take the same request, I redo my grouping with 2 columns, and here I have my magical command having count asterisk greater than 2, and if I'm running this wonderful query, I have the 4 that appears with 22. Okay? So having count greater than 2 works very well. Without the having, we would not have been able to do it. Okay? So what if I try with the sum? It's a good question. I replace count by sum. Let's run this query and we have the same result. Okay, it works perfectly with the sum. So we can put aggregation function for the having. It's done on purpose. It's the cousin of the where. Okay, and if I put the having before the group by, we have the same request, but I put the having count before the group by. Okay, let's run this query and it doesn't work. We see that there is an incorrect syntax at the level of the group by, so the having count always goes after the group by. Okay, so come on, what was it for the having? I hope you learned something interesting. This is really starting with interesting query. So I hope you have having fun, improving your query, and that's cool. Okay, let's move on the next section. Print is used to return an user-defined message to the client. Okay, it's handy for tracking. For example, if you have 1 million rows to do on your table, you can split this 1 million row insertion into batch of 100,000 rows, for example. Okay, so you can follow what you do during a large batch of Transact SQL in insertion, for example. So let's go this and see in a demonstration. Select. We use our usual database, the select with the print. Okay, print, cut, and the message inside the print. Okay, select from my table and print just underneath. Okay, I take the whole request and execute this query, and if I go to the message tab, okay, I get the select from my table print. Okay? So here print the message that I previously put in my print. This can be also be very useful in case of many insertion. Here I do an insertion of 2 rows. I insert first my first line for John Wayne and my second rows here for Michael Douglas. Okay? Followed by 2 print. The first print and the second print. I can select everything one by one, but so to go as fast as possible, I'm going to insert the 2 rows in a row, and I am also going to put the 2 print in my query. Okay, so let's go. Insert and insert the and let's take the 2 print. Here we see that we have a good follow-up of the insertion that have been made on the contact table. Print insertion the first line John Wayne, okay, and insertion the second line Douglas Michael, okay. It's perfect. So the print, I use it from time to time when I do a big update on SQL Server for an update, for a delete, and so on. Okay? It happens to me to do a big deletion of 10 millions or 20 rows. So I divide them in batches. Which each batch deleted, I put a print to know where I am in my query. It's quite practical to track the evolution of your query. That was the main advantage of print. Okay? So let's go for the next session. Offset fetch and next row. The offset fetch clause gives you the ability to extract only one window or result page from a result set. This actually allows you to skip a few lines to have a result set according with the offset clause. Okay? Order by is mandatory with the offset and fetch. We are obliged to put an order by when using this function. Offset indicates the number of line to linear, and fetch indicates the number of rows to return after the offset clause has been processed. Okay? In Firewall this query, here I have my first 15 rows, which are classified in alphabetical order. Okay? And with the offset clause, just here, okay, offset 10 rows, with the offset clause, I'm going to skip the first 10 rows and stop at, you can see here it's Roberts, Julia Roberts, and if I want the offset clause, you can see it's Sharon Stone. And you can see in my example that Sharon Stone is at the 11 rows. Okay? So I skip the first 10 rows with the clause offset. What if I want just the first 3 rows with the next 5 rows? So the syntax is select from contact, ordered by name, offset, sorry for zoom, offset, 3 rows, fetch next 5 rows only. Okay. So I have to do the offset. So I gonna to inner the first 3 rows with the fetch clause. I'm going to take the next 5 rows. And if I run this query, remember Eastwood and row. Okay. And if I take you can see that it's worked perfectly. It starts at Eastwood. Okay, and finish to bit the next 5 rows. Okay, Eastwood and row. It's perfect. And if I change the offset, it's 5, and here 7. We change Michael Jackson and Liz Taylor, and so on. Okay? The offset clause is mandatory with the fetch. Okay? If you don't write the offset, if you run this query, it doesn't work. Invalid usage of the next in the fetch statement. And keep in mind that top cannot be combined with offset and fetch in the same query's expression. If I want select top 2 from contact, order by name, and with the clause offset and the fetch next, you have an error message. A top cannot be used in the same query or a subquery as the offset. Okay. So let's go to the next demo. Trim, L-trim, upper and lower demonstration. Trim, remove the specified character at the beginning or the end of a string. So it removes the space. If you have space in your character, trim, L-trim, and R-trim does it. Trim only appeared in SQL Server 2017. Okay, so if you have SQL Server with a version of 2014 or 2012, it won't work. For our test, we will create a test trim table and we will insert 3 values, including a 4 character on my left for the column value L-trim. Okay, 2 character to my right, just here 2 space, into the column value L-trim, and the another value 2 space to my right and to my left, 2 space here and 2 space here for the last value. Okay, so I have already create the table and insert this value, and if we make the select, you can see that the syntax is very simple. Is select L-trim with the name of my column, L-trim and trim. Okay, so we replay the request with the 3 trim. And let's run the query. Sorry, I forgot to create the table and insert the value. And if I run the query, I have this value. You can see that the 4 characters to the left have disappeared, just here, for the L-trim. The 2 characters to my right also disappear for the L-trim. And for the trim, 2 space to my right and to my left have disappeared for the trim. Okay? So remember the trim remove the space on the left and on the right. Okay, so in some cases the trim, air trim and air trim can be very handy. Upper and lower, allow to you to transform a text into lower or upper case. The syntax is simple, it's like a trim, so you write upper with the name of the column, first name from contact. And if I run this query, you can see that all the values have changed from uppercase. Okay, Michael, Kelly, Clint, and so on. And lower is just the opposite. It changed everything from uppercase to lowercase. Okay? So let's go to the next demonstration. The substring. The substring is used to extract a string of characters from a specified length. Okay? I will always use my favorite table, contact, and if we want just the first name as initial, we're gonna use the substring function. So let's go for the query, select substring, okay, it's the function with my name of the column. So we're gonna use 1 and 1, close the parentheses as initial. First name from my favorite table, contact. Okay, I have just here, and if we play the query, you can see that the substring take only the first character, okay, and stop at the first. It start at the first and stop at the first. Okay, so Michael, L from Liz, and so on. Okay, so you can see that it's pretty easy to set up. You can take strings from a column. And if I want to take the first two letters of the name and the next three. Okay, so copy and paste, and so in this example we have the 2 and the 3. And if I play this query, you can see here fantastic first name and so on. And L, Lee, Clint, for Bruce, for Leonardo, for Brad. Okay. So here I took the first two letters and the next three. I zapped this letter. Okay. I can put 7 if I want. And what's happened if I put 7? You see that the initial has changed. Okay, Michael, and so on. You can take all the characters you want in a string of characters. So in development, the substring can be very useful. So let's go for the next demonstration. Format. Format is a very powerful function that has greatly facilitated development, especially on columns in date format. If you are a developer, you will see that this function will make your life much easier. Instead of making conversion with specific format or a conversion of a column, you will see that the format function is very useful in some cases. So it allows formatting as a string of date and time and numerical values compatible with regional parameters. The syntax is format with the value, the format function, and the culture. If we do a select on our contact table, we are going to focus on the date of birth column. Okay? So we see the format here. The value is going to be the column. Okay? So copy and paste the syntax and make a zoom for the syntax. So here we have the select top one as date and the function format. Okay, with the value, date of birth, the column date of birth, with the format D for day and the culture. French as French, you see here, sorry, English and German from my table contact. And if I were this query, here we are directly the date of birth that is formatted here. We can see the normal date, the date in French, 4 August 1976, the format in English and the format in German. You can see that it's still very powerful and it can make you development much easier instead of making a request that can be very long just to format to a special country. You can just put the format with a very simple syntax. You can also display the day. It's the same syntax. We have just replaced the D by the same D with a uppercase. Okay? And if I run this query, you see the power of format. It detects French, mercredi 4/8/1976, in English format, Wednesday, August 4/1976, and in German. Okay? You can convert currencies too. You can convert currency values according to the given culture. I have already created a table money, with a currency column in money format, and insert just some simple row in this table. And just in this query, we change the D and change the D by a C for the currency. And if I run the query, SQL Server will convert all the rows in dollar, in euro, in English, in Swedish, Arabic, and Thai. You can see the different currency for each country. I will let you take a look on the Microsoft MSDN site regarding the format function. You will see that there are a lot of currencies depending on the country. So I will let you to do some research what format looks like. So maybe you are going to rewrite some code because it must be rewritten for a simply way to run this query with the format function. For information, to see the default SQL language on your SQL Server engine, it's sp configure with the value default language. Mine is configured value is 0. And if I run the exec sp help language 0, it's equal to English. Okay? If you have SQL engine in French, it's 2. In Dutch, it's 1, and so on. Okay? So never forget this powerful format function, which can help you greatly in your future developments. So let's go to the next demonstration. The case when allows to evaluate a condition and returns a result expression among several possibilities. Case when is something commonly practiced on SQL. Okay, it allows you to return a column depending on the expression you want to have in your result. So let's run the select start from contact, and we are going to play with the gender column. Okay, so we are going to say in this column the woman will be the formal will be Mrs. and the man will be Mr. So there will be a new column that we are going to play in the select by making the case when. So let's write the query, select star, and write the case. Case when gender, okay, equal formal with uppercase, then Mrs. And another when gender equal then Mr. I forget the comma just here, and you have to put a hand on the case when from contact. Okay, let's run this query. You have to put the n. If you delete the n and run this query, it doesn't work. Okay, syntax near the keyword from. So the n is mandatory, and run this query. So here a new column that is played in the select by doing the case when. So here the formal is Mrs. and the male is Mr. Okay, you have a new column that is played in the select by doing the case when. Okay, there is also the syntax of the else. If my result is not good, I can give another result that I will affiliate. So in this query, select the age between 16 and 20, then we are still young, else we are not so young anymore. And if I run this query here, so all those who are between 16 and 20, we are still young, 18, 16, 17, and the other, we are not so young anymore, 24, and so on. So in this demonstration, we see that the case when it can be very practical during certain developments where we can have a request that comes out of more explicit value. Okay, so let's go for the next demonstration. The if evaluates a list of conditions. It's like the case when it returns an expression among several possibilities. Okay, if is basically a quick way to write a case expression. Okay, in the syntax it will be if with too high, with the Boolean expression, the true value and the false value. Let's take the case of the case when again. in this example, we can see that the case when the gender is female, then Mrs., else it's Mr. And at the end of the query, the end of the case, we have the head from contact order bar gender. If I run this query, we can see for the gender female we have Mrs. and for the male gender we have Mr. Okay? So we can write it with the if. So select if gender with parentheses gender equal woman, then Mrs. else Mr. and we close the parentheses. Okay, I forget a quote here from contact order by gender. If I run the query, if you don't, yes, I make a mistake, I change, I put the good if we too high, and if we check the result, it's exactly the same thing. For the female we have Mrs. and for the male we have the Mr. Okay? And if we enable the execution plan and run the same query at the same time, the both query at the same times, we can check that it's exactly the same execution plan. 50% for the two queries. Okay? So there is no big difference between the if and the case when. If you want a simpler syntax for the case when, the if exists. Okay? So let's go for the next demonstration. Left and right. Left and right are something you will see very often in Transact SQL. It allows you to extract the end of the string by defining the desired length. If we do a select from my table contact, we gonna play on the name column and the first name column. Okay? Let's check the syntax of left and right. Left with the name of the column, comma, and the number of characters we want to remove for this example Jackson. Okay. Right, it's the same syntax for the left with the name of the column, comma, and the number of characters we want to remove. Okay, if I run this select, what do I get? You can see for the column Jackson, left name, okay, he took just the two first characters, okay, on the left, Ja. And for the column first name, d'accord, he start from the right and stop to the first 5 characters, okay, and the name is Gael. Okay, you understand that Gael is Michael. You can even concatenate the field. It doesn't help much in my example, but you can concatenate fields with left and right. Remember, keep in mind, you can concatenate a lot of other fields. This is just an example. So, in this example, select name plus right first name. if I run this query, so here you can see that it gives a word first name. It can, for example, help you in naming your future kids. Okay, we concatenate the name that are here, name that are here, and the first name here. Okay, Jaquel, Thalys, Clint, Wilbrus, and so on. Dinardo, it's not bad, Dinardo. We just did left plus right and gives this beautiful name. Okay, so let's go for the next demonstration. The choose function. The choose function returns the element to the specified index from a list of values in SQL Server. I will do a small demonstration for you. Use function as usual, and I do a select choose with this syntax. Okay, this following example returns the first item in the value list. In this example, 1 for France. I want to take France in this list of values, Belgium and Ghana as country. I take 1. Okay? And if I run this query, you can see that it's France. It works perfectly. And if I want to take the Belgium country, I think you understand, I put the 2 here. Run this query, and this is Belgium. For now, it's quite simple. And if I set the index to 0, just here, what does the select give? It returns the null value. Okay? Okay, we will see if we can replace the case when with a choose. Here I say when it's 1, then January, then it's 2, then February, and so on, and 3 for March, and so on. And if, so you can see there is a new function, that part. Of course, we go from that part further in this course. So the syntax is that part with, it's the part on the column. Okay, that part, I want the month on this column. If I run this wonderful query, you can see that Michael Jackson, whose date of birth is 8, so August. For Grace Kelly, it's May, 05 for May, and so on. George Clooney, 01 for January. Okay, so you can see that the case when works very well for my query. The question is, can choose do it? Let's do a choose. We're going to define a value for it in its table. Choose with the date part and the name of the column with the month, and we enter all the values for the choose, the index, X. So January, February, and until the December. And if I run this query, and we can see it works very well. For Michael Jackson, date of birth for August, and so on. May, and January for my friend George Clooney, it's okay. It's worked perfectly. So the choose can be practical for you development. That's all you can do with the choose value. So let's go for the next demonstration. KLS. KLS is also something we see very commonly in Transact SQL. it will evaluate the arguments in order and returns the current value of the first expression that does not initially take the value null. Okay? A simple example. We do select coalesce with two parentheses with a null value, okay, and the next value. Coalesce. So if I want this query, it will zap the first null value, okay, and we'll take the one just like that. So coalesce allows us to not to evaluate null's value in the query when we have a lot of them in our select. So let's create a simple table with 3 columns, number 1, number 2, and number 3, and insert just some simple row with null values. No values and the another row with 2 null values. And if I want the select for my number, I have some simple values in my table, news and null. I think you understand. See, if I want to remove the null value in my select, so select queries number 1, number 2, and number 3 as number of phone from my number. So if I run this query, you can see that coalesce remove all the null values in my select. So it's going to be smart enough, and it's going to remove all the null values, even the 2 null values in the 2 columns where there are the 2 values here. Okay, so you can see that it's smart enough to do it, and it can be very handy in some query, if you don't want the null values to pollute your select. Okay, so let's go for the next demonstration. Drop if exists. Drop if exists will simplify the work when deleting object on SQL Server. It's new from SQL Server 2016, and it makes your work much easier. When you will see it, you will say there is finally this function. I have already created a simple table, simple table test, and with the whole style, old school style, we write a delete by this way. If object ID with the name of the table to drop, TPU is not null, drop table. Okay? And it's work. Okay, the table has been deleted. It was quite complicated to set up, not very complicated, but it still had to be right. Okay, and let's create again the table, and here we see we have simplified the way of deleting SQL object. Drop table if exists with the name of table, and that's enough. You can see that the syntax is much simpler, and it's the same result. The table has been deleted. Okay, it also works for a lot of objects on SQL Server, for the assembly, the database, the default, the index, the procedure, and so on. For the sequence, the type, the view, the type, the view, the schema. Okay, so now if you are a 2016 SQL version, always use drop if exists. Union and union role. Union and union all is a command that concatenates the result of two or more queries. On the other hand, each of the queries to concatenate must return the same number of columns. If you don't take the same number of columns, when you make an union, it doesn't work. Example of two tables, we create two tables, create table 1, and insert just two single rows, Wonder Woman and Captain America. And the second table with client 2 with Wonder Woman in duplicate, okay, and Dagrador, my old friend. Let's create the table and execute the both select. Here we see that there is the duplicate in the value Wonder Woman. Okay. So let's see what select union gives. What will it do? You can see the syntax is very simple. Select from my table client 1 union. Select from my table client 2. Okay, it's quite simple. And you can see he took Captain America, Dark Vador, and Wonder Woman. So he concatenated the two select from the two tables. He gives the total result of the client table. Okay? And you can see that the duplicate has been deleted. No duplicate in my union. There is also union or union all. It allows you to take also the duplicates. You can see this syntax. You have just to add all. Okay? And if I run this query, I have Wonder Woman 2 times. Wonder Woman and 2 times. Okay? Union, it takes out the duplicates. Union all, it doesn't take them out. So when you think of union, you think about the concatenation of the table. Okay? So let's go for the next demonstration. The joins. Joins are commands that you will see very frequently in SQL query. Okay? You must absolutely know the joins when you are going to set up your first slightly more complex query. Discover the power of a join and how easy it is to install. You will realize that it's not that complex to write join on SQL Server. Okay, they are designed to put two or more tables together to search for answer to question. Okay, a join thus makes it possible to combine the column of several tables. Think of your database as a huge puzzle. Okay, so each table is a separate piece. So our job is to put all these pieces together. You have to learn inner join, full join, left join, and right join, and so on to put this piece of the puzzle together. Okay? You can see here an example of the join in this diagram. Join I use to combine a table of or several tables. This is the correspondence between the two tables on the floor, and here the result, that a join between two tables. So let's go for the first demonstration for the inner join. The join. It's possible to join two tables between them in SQL Server. Okay, the joins allow to associate many tables in the same query. They allow you to obtain results that combine data from several tables in an efficient and very powerful way. Join I used a lot of on SQL Server. You will see that it's very useful to join table. The syntax is easy, and you can see that there are many types of join. There is the inner join. Inner join, in fact, it's an internal join to return records when the condition is true in both tables. It's one of the most used join. It's the one you will see the most often. With the inner join, if you have two tables, left table and right table, that we are going to join, it's going to join the matching data between the two tables. Okay? Anyway, we are going to see this in the demonstration. The syntax is select with the customer colon alias A. Okay? By making the join on the customer table alias B, and at the end by specifying the two columns on which I want to join. Okay, so come on, let's see all this in the demonstration.
Okay, so let's go for the demonstration about the inner join, the internal join. Use formation as usual, and I create two tables. One table called orders and one table with the name of customers. Okay, it's good. And insert some values in them. Insert 9 rows and insert into the table customer how 5 customers. And if I do the to select, we have the two tables, a customer table and a orders table. So what we are going to do, we are going to join these two tables. This one, the table order, and the table on the bottom, the table customers.
So my first question is going to be, I want to bring back the customer who have an order number. Okay, let's make a zoom. You can see here who has order. Okay, number of order. Okay, their number, and I want to join them with the 5 customers just on the bottom. Okay, I want to show you just the customer who have made an order. So logically, if we do a join, we're going to show the matching values. So we will have the one just here in the ID customer column, the 3 and the 5. Okay? So there we have an order number here. Okay? So let's write our query. Okay. Let's go select. So ID customer, because we want to do a join on this column, so ID customer from orders. Okay, and we give an alias to the table. So hey, for example, and we also give an alias for the ID customer for this table. Inner join. Let's do a join between the two tables. on the customer. I think you understand. We give an alias B to another table, the table customer, and I do a join on the two colon ID customer. So hey ID customer equal B ID customer. So in this example, I do a join on hey ID customer in the order table hey, and the Hanover join on the B ID customer for the customer table, just right here. Okay? If I want to see if my syntax is good, just click on the check here, parse, check, and command completed successfully. So what does the select do? Let's run this query. I did bring back customers 1, 3, and 5. I've joined the two tables and I have got the associated order numbers. Okay, so we have the customer that have order numbers. Then I want the first and last name of the people with in my query. So let's make a zoom. We had the column name with the first name column. Sorry, I put the alias B because the column name and first name belong to the customer table. Okay, understood? Let's run this query. I have the name, the first name, and the number of orders, which appears in my query. Okay? Everything is perfect. And if I change the first name, if for example I put hey, okay, and if you can see here it's red, and if I run this query, invalid column name for the first name. Okay, so I don't have the first name column in the customer in the order table. Okay, then you have to know that the inner in the inner join is optional. If I take the same request and remove the inner, okay, just a join without the inner, and if I run the query, the result is good. Okay, it's the same thing, it's exactly the same command. So inner is optional, but generally developers like to put an inner by default, but it's optional. You have to know that. So contrary to a popular belief, we had a lot of posts on the forum about SQL that talk about impacting then join data on themselves where we join. So if in example, if we change the joining order on this query, ID customer equal B, and if we change, okay, B and he, just here, I invert the meaning of the column in the join. So what's going on if we run these two queries is exactly the same thing, the same result. Okay. In short, changing the order of join does not impact the result of your request. Okay, so let's go for the right and left join demonstration. The left join it's an external join to return all records from the left table with the corresponding values from the right table. Okay, to better understand, it's schematized by this drawing. Okay, we take all the values from the left table with the corresponding values from the right table. But we don't take the values from the right table. Okay? So you see in the syntax that instead of putting an inner join, we put a left join. With the left join, we can do a is-null filter. Okay, what is this is-null filter? The is-null filter on the left join will bring back all the lines, all the rows in the left table, but that doesn't match the right table. So what it looks like in the drawing. So we bring back just the value of the left table, and at the end we put where on the right column. AID customer, for example, is null. Okay, so it will just bring back the values of the left table. It will filter them. Same thing for the right join. It's an external join to return all the records from the right table with the corresponding value from the left table. Syntactically, as you can see, we move left and put the right join, and it returns the right values that correspond with the left ones. Okay? With the is-null filter, it's the same thing like as the left join. We are going to bring back just the rows from the right table, which has no match with the left table, like this. Okay? So, without the intersection of table A and table B, which is the left table. Okay? Okay, let's go for the demonstration of left and right join. We do a select of the orders and customer table, and we have always the same data. Okay. The question is which customer is not attached to customer ID in the order table. Here we have the customer Albert Einstein and Chuck Norris. That the customer ID is 12 and 13, and are not reference in the order table. Okay, there is not associated order number, and we want to know how to find the 12 and 13 in the query. We won't be able to do an inner join because, as you have seen before, it will only output the correspondence between the two tables. So we will try to find the way to output just the 12 and 13. Okay? We said to ourselves, in this case, we are going to do either a left or a right join. While in first, do a left join at the beginning. As you can see, we replace the integer by just a left join. Okay? And if I run this query here, so what SQL did? It took the matches from the customer table here, okay, for 1, 3, and 5, here, that match with the order table, okay, and plus the values 12 and 13. Okay, so it's normal to have 1, 3, 5, 12 and 13. Okay, so in this case we are obliged to add the filter. that it's to say we are obliged to filter the data, and we are going to tell him take just the values corresponding to the left table. Okay, so here we take just the left join from the left table with no correspondence on the table customer, the table B, with no value from the right table on the B value, and the correspondence that is with. In this case, I have to add the null. So I do select, and I add where ID customer is null for filter the data. Let's run this query, and I have 12 and 30 Albert Einstein and Chuck Norris. It works perfect. So there I have the answer to my question, which client is not attached to an ID client in the order table. Okay? We can also see that the outer join, just here, is optional. Okay? If I put an outer here, it's exactly the same result. In some query, you will see the outer. Okay, it's optional. You can also do the same thing with the right join. Just reverse the customer and the order table. Okay, we change. Customer is now on the right and order is on the left. We reverse the two tables. We put the customer B in the right join. That means add the join on the right side of the customer table. And if I run the select, it's the same result. Okay? It's the same thing, right join, left join. And we can also say that the outer right join is exactly the same out as the outer left join. It's optional. Okay? So you see the power of the join. How far can we go on the data filter with the isNull filter? We can go very far, so it's very powerful. Okay? So come on, let's go to the next demonstration. Full outer join. Using these commands allows you to combine the result of both tables. It allows you to associate them with each other thanks to a condition, to file with null values if the condition is not respected. Concretely, the full join returns all the lines, and if there is no match, it shows a null. It even returns the matching rows, the matching lines. With the isNull filter on the full outer join, it will bring back all the rows of the table A and B, but it's important, not the data that match between them. It's like the left and the right join. If we put isNull, it doesn't bring back the matching values. Okay? So let's go together to the demonstration. Okay, so let's go for the full outer join demonstration. And now it's time to the full outer join with both select at the same time. We will take the ID client, colon, ID customer, and we will put a full outer join on the customer table and run the both select at the same time to see what it gives. So run this query. And so what's happened? For the full outer join, just here. So I brought all the rows from 9 to 4, from 1 to 9, just here. Let's make a zoom. 1, 2, 9. From the orders table plus the 2 rows from the customer table, just here, for the 12 and 13 rows. Okay? So we have 11 rows for the full outer join request query. So we can see that it brought all the corresponding rows, the 1, the 3, the 5, and so on. On the other hand, there are 2 null, because the 12 and the 13 are not corresponding, so it gives us the null value as I explained earlier. Okay? So it brings back all the rows, and the ones that don't match are shown with the null, but it still bring back the name. Okay, so it matches that in this diagram. So it broke back all the lines from both tables plus the matching value between the 2 tables. Okay, and what it I've changed the column. I put in the place of ID customer here, B ID customer here, B ID customer. Okay. I play the query with the to select. And what does the select give? Just it broke back all the lines 1, 3, 5, 12, and 13 plus many null. Okay? So it brought back for 1 here, 3, 5, and 12 and 13. So he brought back the 1, 2, 3 from the command table, but not 2, 4, 6. There are no value, so it shows a null. Okay? So we are going to filter on the is null. Okay, you can see that here that all the rows on the client table, okay, the customer table, sorry, we see that 5 null corresponding to the order table 2, 4, 6, 8, and 9. Okay? So that you understand better, I'm going to do a select with the to select and the full outer join with the hey ID customer is null. Okay? So let's run this query. And the full outer join, broke back the 2 lines, 12 and 13, that are not in the orders table. Okay? Is on the customer table, but not in the order table. With the filter is null. So in the schematic, that's what it looks like. Here it broke back all the rows from A and B, but it didn't bring back the ones that don't match between those 2 tables. So it's normal that is brought back just the 12 and 13 that don't match that table. So the full outer join is very useful when you want to see all the rows that don't match each other. Okay, is the outer optional? I put full join, and you can see that it's completely optional. Okay, if you run this query, you have the same result, 12 and 13. Okay, that was the demonstration on the full automation. You can see that it's very powerful. Okay, let's go for the next demonstration. The cross join. The cross join is none other than the Cartesian product of two tables. The Cartesian product on SQL of two sets is a generalized multiplication. Okay, if for example we have two tables, it will associate the row of the first table to the second one. This is something we rarely see, but in some cases we may need it, and it exists on SQL. We can associate the row from the first table to the second line, bring everything together. The syntax is quite simple. It's a join on one column. Okay, it's a cross join on one table. The syntax is select from customer B, cross join on the another table, the order table. Okay, so come on and let's see this in a demonstration. Okay, let's go for the demonstration about the cross join. Use function. As usual, I do a select from of my two tables, and I still have the same data. Okay, for the two tables, 1 to 9, and my 5 favorite customers. And here we go for the query. We can see that in the cross join there is no join on two columns. We do a cross join on one table. Okay, we can also remove the alias. They are useless on the cross join. We can remove it. Okay, and we will run the to select at the both time. So we see that in the cross join we have 45 rows. Okay, if you click on the cross join, we have 45 rows. Okay, so why 45 rows? We realize that the first 9 rows we have an order number that is reflected here. From 3712 to 3238. Okay, it's reflected here. Okay, but it took Bill Gates 9 and replicated it 9 times. Okay, Bill Gates 9 times. Then he took the second value for Frank Sinatra. Okay, and replicate it from the 3712 to 3238, and so on for Michael Jordan and Albert Einstein, Chuck Norris, and so on. Okay, so it took the 9 rows just here and multiply by them the 5 rows in the customer table, which make 45 rows, hence the result. This is what we call a Cartesian product. What it did, it multiplied the rows of the first table in the second one, and if we change the the order, the join order, just here, we change customer and order tables, and we have exactly the number of rows, 45 rows, okay? So this is called a conjoin. I'm going to multiply the number of rows between two tables or more, okay? So come on, let's go for the next section. We're limited to one join on only two tables. Fortunately, we can do join on several tables. Luckily, it exists for a reason of simplicity, and fortunately, we are not limited to this level on SQL Server. Let me show you this. I always use the same database formation, okay? And let's create a new table, loyalty card. Let's create a table and insert some simple value. Yes, no, for 12 rows. Okay, it's done. And if I do all three select, I have ID customer for the free table. Okay, ID customer here, here, and here. Okay, so that's for the setup. Question: I want customers who have an order number, but also who have a loyalty card. So the query for the customer who have an order number is this one. We already seen before. We have 3 persons. We get Senator Frank and Michael Jordan, all my old friends. But I don't know in this query, sorry, who has a loyalty card in this table. So I have to add the loyalty card in my query. Okay, so let's add a new inner join. Okay, for loyalty card, alias C. Okay, on B ID customer equal C customer ID customer, sorry, and I think you understand where C loyal equal yes. Okay, and if I'm running this query, then by a miracle we have only one person. Okay, Bill Gates. So in this demonstration you can see that we can do many join on many tables. Okay, there is no limit on SQL Server for the join, the number of join. So that was the demonstration for many tables. So let's go for the next section. Cross and outer apply. Maybe you have seen them in an SQL script and you didn't really understand the usefulness of this type of join. So we will talk about them in this demonstration. Cross apply is equivalent to an internal join, okay, like an inner join, and outer apply is equal to a left join. Okay, we are going to see it in the script, and let's run the first query with the classic inner join, as you saw before in the previous demonstration, a classic inner join, and we have 3 lines, 3 rows. Okay, we get Frank Sinatra and Michael Jordan, my old friends. So let's go, let's have fun and write the cross-apply query. So let's go, copy and paste. So select B ID customer, B name, B first name from customer. For the moment there is nothing complicated, and let's write the cross apply with open a parenthesis, select from my second table order. Okay, let's copy paste from orders, and we replace the on by a where close, and we close the query with the parenthesis. And don't forget the stars or the asterisks. And if you try to run this query, we have an incorrect syntax near the parenthesis. Okay? To fix this problem, you have to put the A after the parenthesis. It's what's called a derived table. Okay? Of course, we will see that later in this lesson. Don't panic. And if you run this query, it's good. If we have exactly the same request, the same result, sorry, for the two queries. Okay, 1, 2, 3, and 1, 2, 3. It's perfect. So you can see that the cross-apply is equal to an internal join, in fact. Okay, it's exactly the same thing for the left join. We are going to replace the cross by a with the outer. Okay, it's exactly the same query, so we replace the cross with by a outer. And if we run the left join and the outer apply in the same times with the here for the derived table, just here, don't forget the he. You can change the he and put a b. Example b or c. And if you run the both query, we have exactly the same result. 1, 2, 3, 5, 12, and 13, and exactly the same query, just on bottom. Okay? So we see that cross apply and outer apply are the same as left join and inner join. Update with the join. You can make a join in an update. I will show you that. Use formation as always. I forget to use formation. Go. Okay, as usual. And let's create two simple tables for our demonstration. Table 1, and insert just 4 rows, and insert and create another table, table 2, and insert. Also insert 4 rows. And let's run the 2 select and make a zoom. In this example, we are going to change the values for the table 2. We replace the value 5th and 6th by 3rd and 4th. Okay, because the value on the table 2 are not good. Okay, so we are going to change 2 rows. So we are going to update these 2 values. Okay, when we do an update on the join, we hide the from. Okay, because you have to tell it from which source you want to update the fields and have to add the set. Okay, so let's go for the update on the join. So update. So I want to update the table 2 for change this to value. So I update this value, update this table, sorry, set column 2. Okay, this one. I want to change this column. So I put the alias T1 because I show you just after column 2 from, I think you understand, table T1, table 1 T1, okay? So here we update the column of the table from the first table onwards, okay? From my source table, from my table 1, and let's make a join, table 2, T2, alias 2, on T1 column 1 equal T2 column 1. It's simple to write this query and to finish where T2 column 2. So T2 column 2, so this one in 3 and 4. Okay, so I want to change these two values. And let's run this query. I have an error message and change the column. It's not the good column. T2 column 1 and update the query. And you can see that we have two rows affected. Okay, and if I run the new select, you can see that the values in the table 2 have been changed. Now we are good. 3 third and 4 fourth. Okay. So we see that it's not a very complicated syntax, but there are people who use cursors and all that follow to update two fields when we don't have to do it. We can do a join, with a simple update. I am obliged to make this video because it's possible that you may see hint in the join in some request. Okay, of course we are not going to make a performance video as this is not the subject of this formation, but it's some for information. So we can change the order to make a join on SQL. It can be changed. I'm going to tell you very briefly about the join operator that you can have on SQL Server. The hash join. It's a powerful operator that it used for medium and big volumes of data. It can be used sometimes on small data volumes as well. Technically, it's going to create a table in memory, what's called a hash table, that will hash the join column, and in the second phase is going to create a table that we call the probe phase. Okay? So let's start on the simple join and look at the execution plan. Don't forget to click on the execution plan button, icon. Okay, I click on it and let's run the inner join. If I getting a look on the execution plan for inner join, it's a hash match inner join. Okay, is the hash match operator that has been chosen for this operation. Okay? So technically, it first built a hash table in memory. Okay, and then from each row, from the bottom entry, it analyzes the hash table to generate all the matching rows. Okay? So we can, from the inner join, add between the inner and the join a int. Okay? So in this example, it's the hash. So take the hash. Let's run this query and we can see that it's exactly the same execution plan. Okay, there is no difference. It's exactly the same execution plan. Okay? And if I run the query together, we have exactly the same execution plan. So okay, hash mash and hash mash. So we are going to see next the merge. The merge is a fusion join that is used when the two sets of rows are pre-sorted according to join expression. Generally, it's used for very big volumes. It's very powerful too. So instead of hash, we can use merge. Okay, so let's run the query with the merge, and you can see that the join operator has changed. Now it's the merge join that has been used. Okay, and if we compare the two execution planes, which one is greedier? You can see that the hash join is 40% and the merge join is 60%. Okay, so the merge join is greedier than the hash join. In this query, in this example, there is also a third way to make a join. This is the nested loop. Okay, nested loop is used for very small volumes. This is the simplest physical implementation that SQL choose to make join on very small tables. You can see that we change the merge with the loop. And if I run this query, if we get a look on the operators, we can see here is the nested loop. Okay? So if we're running the hash, the merge and the loop together, let's run this free query. We can check very quickly. 11% for the loop join, 36% for the inner join, the hash, and the merge, 53%. Okay. Here we have a practical case. You see that the nested loop is still less greedy than the hash. So, in some cases, can't I play the hint on the join to see if I can better performance? Okay. Personally, I have rarely seen it where I have to change the way I do a join. In 99% of the case, SQL does it very, very well. Okay? It was just to show you that you can change the join orders by putting a hint. There is also remote. Remote here. Remote is if there is a remote linked server. You can put here a remote. I run this query, but I don't have in my server a remote server, so it takes the hash match in this example. Sorry. Okay, Here generally you will have a remote, so it can be useful in some case. Remember that you can only use remote in an integer. You can use a remote in the left join. It's noticed just here. A remote in can only be specified with the integer clause. Okay? We can also write this way, but the hash option here and add option and add the hash join at the end of the query. You can write by this way. Same thing for the merge here. Same thing for the loop. Okay? If I run this free query, see, it's exactly the same thing. Okay? Hash match, merge join, and nested loop. So in this demonstration, we saw four ways to write hint on SQL join: add join, merge join, loop join, and remote join. Okay, don't forget this hint if you see one hint or more hint in SQL script. Okay, but now you know what for which reason is used. So let's go for the next section. Except and intersect. You don't see them very often, even on Transact SQL, but they exist. Except returns the separate rows on the input query on the left, but not find by the query input query on the right. Okay? Intersect return the distinct rows or line that are generated by both right and left input. I think you got it. It corresponds to a left join and an inner join. Okay? It has intersect correspond to an inner join, and except correspond to a left join. Okay? So let's go together for the demonstration. Intersect and except demonstration. Use formation as usual, and let's run the classic inner join as we saw before. We have 3 rows: 1, 3, and 5. Okay, for the classic inner join. Okay, let's write the query for the intersect is the same thing that the inner join. You will see that the intersect query is very simple to write for customer, and you have the intersect just the first select, and you take copy and paste, and you have just to change the table. You can see that it's very simple to write. Select, intersect, and the second table, just bottom. If I run this query, I have exactly the same result: 1, 3, and 5. Okay? And if I also put the execution plan to see which query is the fastest, let's run the query in the same times. Execution plan, and we can see that in the execution plan the intersect takes 43%, and the join just here 57%. Okay, so the intersect is a little bit more speed in the join. Okay, except has the same syntax as the intersect. So let's copy and paste So here you can see the request with the late join, with the filter null, the nothing, as we saw in the previous demonstration, nothing, with the subquery, and we can also write the except. So I change the intercept with the except. So we little, just see here, except and run this query. So normally we have this result, just 12 and 13 for Albert Einstein and Chuck Norris, my old friend. For the nothing is the same result, and for the except query I have exactly the same result. Okay, 12 and 13. Okay, so we can in some cases say why not rewrite some request, some query in except, or why not also in nothing. Okay, and if we check the execution plan, 22% for the left join, 22% for the nothing, but you can see that the except have not a good result, 56%. Okay? So don't forget that you can rewrite the left join with the except. So let's go for the next demonstration.
Small section on conversion on SQL Server. Why did I put a special little section? Because conversion are operations that we see very frequently in Transact SQL. You will see in many development that the cast, convert, try convert, and try cast function are used a lot. So I have to tell you about them so that you won't be surprised when you find them. Okay? So let's start with the cast. The cast function is a language. SQL language is a transtyping function which converts data of one type into another type. So we do a select and we will work on the date birth column, date of birth column. So we will try a conversion with the cast function. Okay, cast with two parentheses. Okay, so the column that we want to convert as datetime true. Okay, you can see that the syntax is quite simple. So in this example, we are going to convert this column in the datetime true. Let's try a simple select. You can see the format of the column with the year, month, and the day. And if we try a conversion with the datetime 2, let's run this query. Here you can see that we have now the milliseconds. Okay, we have convert the datetime column, the date of birth column in datetime 2. And how about playing both requests at the same time with the datetime? If we run the select both, we see that the datetime do not returns the millisecond, while the datetime does. Okay. Another example, I will try to convert the name, the column name. Sorry, it's a mistake. The column select cast the name column as the int. Okay, we're going to try a string column with some characters as a int with numerical. Now you know that a string can be converted to a numeric data. We have the error message commencer failed when converting the varchar value Jackson to that data type int. Okay? However, we can do the opposite. We can, for example, convert the age, which is in a int, in varchar. Okay? Select cast age as varchar 20. Let's run this query, and there is no error message. So we can convert data in numeric types to string. Okay, there are some applications that for a reason we want to do what is called an implicit conversion of data from numeric type to strings. So we will have to do a cast, otherwise the application will not work. The convert function on SQL converts data from one type to another in a manner similar to cast. For example, if we do a select, it's the same syntax from the cast. So we remove the as by replacing a comma. Okay. And if we run the to select, we will see that we have two different results. Convert int 52.79 will convert to 52. Okay? For the convert to varchar for 63.3, it's the same result. Okay? For a conversion in varchar. So convert inner int. For this example, we round off and give 52 and convert. Varchar with 63.3 will give a string. Okay? On the other hand, there is the third extremely important parameter for the convert function. It's the format style you want to give it. For example, we have a date of birth colon in a date. Okay? With this type of data. I can give it, int result form. Here, for example, I want to convert this date of birth in a British format. So I have to write select convert varchar, comma, with the name of the column and the format that we want to convert by date of birth column. Voilà. So I want to run this query and you can see that it's worked perfectly. Result in British with the convert 153 and it converts to a British format. Okay? Same thing for the German conversion. I put just 104 and it's in the format German point with the point. And to finish, here the conversion in Italian. Okay? In format 105. And just below, a great link for the conversion table. If you click on it, you arrive to this table. Okay? You have 105 for the Italian, okay, 104 for the German, and so on. USA, 110, 110, okay, and
so on. Okay? So that was the demonstration about the convert and cast function. So let's go for the next demonstration. Try cast and try convert. Try cast will return a null if the conversion fails. Let's see the first example. Select try cast with abd as int as result. You can see the syntax of the try cast with one parenthesis and the second parenthesis. Okay? I think you understand. It's impossible to try to cast this character as a int. Okay? So we see that it returns a null instead of the error message. Okay? It returns a null. Let's try with the cast. Select cast as a hint, and we have an error message. Conversion fail when converting the varchar value abd to data type int. Okay? And let's try a try convert. It's the same syntax of the try cast. We just replace the try convert, and it's the same result that the try cast. It returns a null. Okay? The difference between try convert and try cast is the same as convert and cast. We can just add a third value to convert. Okay? So in this example, I added a comma, and for example, at random in conversion information I put 103. That's the difference between try cast and try convert. And if we try the convert, it's the same result than the cast. Conversion failed, and so on. And if I try the try cast with the case when, select case when try cast, ABC as it, if it's null, it fails. So if it's null, it's KO, else, okay. And if I run the query, I have a KO result. Same thing for the try convert, I have the same result. Try convert, just here, and I have the same result, KO. And if I replace the ABC by 1, now it's changed, it's okay. It returns conversion okay. And if I insert a try convert, a try cast, sorry, in if try cast, select if try cast 1 as int, if it's null, it's fail, conversion KO or convention okay as a result. I think you find the result convention okay because 1 is a hit. Same result for the try convert is the same result. Okay, so you see in your development if you can't do a try cast or a try convert, so you can reduce your conversion errors. Okay, so let's go to the next demo. Here is a chapter dedicated to view and store procedure. It's of course very important to learn these two objects on SQL Server. We will see the main difference between these two objects. Okay, assimilate well this session which are going to follow, because you are going to make your first SQL script. It will be absolutely necessary that you know this object on SQL Server. Okay, so let's see right away the power of these two objects on SQL Server. What is a view? view. A view is kind of a virtual table. It actually contains the result on an SQL query that you define when creating a view. It only contains the result of an SQL query. Okay? A view is used exactly like a table in SQL queries. So it makes writing queries much easier. The view is simply a virtual table. Okay? So let's go for the demonstration. Okay, let's go for the view demo using formation database as usual. So I have the request just below. There is something that exists for this kind of query that we need to set. We call it views. The problem is that I have to save the query each time or type it again by hand. Okay, which is a bit complicated every morning. So we are going to create a view. Okay, so the syntax is create view. Okay, as create view with the name of my view as, and I put my code. Okay, you can see it's very simple. Just create a view. The view has been created, and if we look for the management studio, sorry, if I do a refresh on the view, I have my view which appears, which I created previously. It also has column like a table. Okay, so in the view folder, column, and the 3 columns total, gender, and date of birth. A column as here, total, gender, and date of birth. Okay, so I will select with view. It's like the select from a table. It's simple. Select from my simple view, and I have my result. Okay, it's the same result that the query inside the view. Understand? I can also put filters in my view. I can call just a column. Okay, I can like a table, select total from my simple view. Okay, and what does this give? Just 2. So no need to retype the request every time. It's now saved by a view. So I no longer need to retype the code. I have to type every morning to get my result. I put in the view and I am safe. We will do a practical case in terms of security. For example, I want Michael to see only people under 30 years old. Okay? So for Michael, create view, select from contact where age under 30, and another view for John, only see wells those under 30 years old. So create 2 views for Michael and John. And John, it's for the person where age greater than 30. So let's create the 2 view, create view for Michael, and create view for John. And if we look in Management Studio, you can see that the 2 views have been created. Create view for John and create view for Michael. Okay? And what does the select give for the 2 view? So select from view John, and you can see that John have a view with the age greater than 30. Okay, so John can only see well people over 30 years of age. you can also ensure a better filtering at the security level. Okay, please notice this. And if I went the select from view Michael, you can see that Michael see only the person which with the age under 30 years old. Okay. Don't forget that it's a good option for the security. Okay. If I want, for example, that two people don't see the same data, so we can create view. We can think of that. So can we put an update in a view? Create view as update contact. If we can put an update in a view. It doesn't work. It's not possible. Can we put a delay in a view? It's the same error message. It doesn't work. And can I put an insert? Not possible. Only the select can be put in the view, contrary to the storage procedure. We will talk about them in the next section for the storage procedure. In a storage procedure, we can put an insert, a delete, an update, a select, whatever we want in them. Editing a view. For example, I want to change a piece of my query in my view. I want to change the mail by the female. So I want to change it's an alter view. Okay, that's like create table, alter table, it's alter view. Okay. If you want to modify an object in SQL Server, it's alter. You can do this with Management Studio. Right-click, script, view as, and alter. Okay, to a new career editor Windows. And the alter is here. And if I change the mail mode, I run execute. And if I do a select from my view, I can see that the result have changed. Now it's from 1 for the total of 1. Okay, alter view for change a view. To rename my view, it's like SP rename like a table. SP rename my view, comma, and the new name I want to give to my new view. SP rename. Let's run this query, and if I do a refresh on Management Studio, you can see that view now it's view 2. This can also be done with SSMS. You can change. You click on the touch F2 or right click on rename, and you put the name simple view. And for the delete, it's drop view. Drop view as drop table. Okay? Drop view, simple view, and the view as disappear in Management Studio. You can see that it's quite simple to drop view in SQL Server. So in this demonstration, we have seen how to create the view, modify, renaming, and deleting a view. And we will move on the next section now. What is the storage procedure? I am a big fan of storage procedure. It has a lot of benefits, especially at the performance level. This is not the point of the topic. The goal is to explain to you what is the storage procedure. Okay? I am deeply convinced that the storage procedure is the best thing to play a batch
transaction on SQL Server. Okay? A storage procedure is a set of SQL statements compiled in the database. Okay? It can contain the statements delete, update, and insert, not like the view. The storage procedure also allows a simplification of the SQL code like the view. It benefits from the power of the SQL cache. Once you launch a storage procedure, it's compiled into the SQL cache plan in the memory, knowing that RAM is 1,000 times more efficient than the disk on average. We quickly understand its benefits, hence the great interest of the storage procedure. Okay, so that's why I'm a big fan of it. I'm talking about it just for information. In terms of security, the user will not have access to the tables. But we'll go through storage procedure to also provide security. Okay, so let's go for the demonstration. Let's go for the demonstration of creating a storage procedure. I have insertion to do every day. Okay? I admit I am a little fed up with always making the same insertion. What I can do to simplify the code, I can put it in the storage procedure. So the storage procedure, we start with batch which will store inside it. So the syntax is create procedure, like the create view or create table, create procedure with the as, like the view. Okay, so you replace view by with procedure. Okay, so I am creating this storage procedure with the insert into contact just one row, Dark Vador. And let's create the storage procedure. And if we do a refresh, it's in the programmability. Sorry, it's not easy to say programmability storage procedure, and you can see that a new storage procedure has been created. It's PS insertion. Okay. So what I'm going to do, I'm going to play it. Okay, for launch the storage procedure, you have to use the exit or execute. Is the same thing. Okay, I always write exec, but you can write execute. Okay, so let's go. Let's run the execute command. Execute with the name of my storage procedure. And you can see, you have one row affected. Okay? So I think it's worked. And if I run the select to check if my storage procedure has worked, we can see that a new row has been inserted. It's my friend Dark Vador. Okay? The update. Can we do an update in a storage procedure? I will create a storage procedure, PS update. Okay, create procedure, PS update. And I write an update inside the storage procedure. Update contract. Set name dark2, where name dark22. Okay, let's create the storage procedure, and if I do a refresh on Management Studio, I can see PS update has been created. And if I run my PS update, sorry, very mistake, dark2, where name is dark.
And if I will master procedure, I have one row affected. And what does the select give? You can see that now it's dark too. Okay? And can we do a delete? Create procedure place delete from contact. Okay, delete from contact where name equal dark2. Okay, it's the same thing that the insert and the update. Create procedure, and if I want master procedure and do a select from contact, I can see that dark border has gone. Okay. If we look for Management Studio, you can see that right now we have 3 storage procedures: PS delete, PS insertion, and PS update. If I want to change, for example, the delete in the procedure, the storage procedure PS delete, I can do like the view alter procedure and change the name. Okay, in this example is strip. So alter procedure and execute the storage procedure delete, one row affected. And what does the select give for strip? We have no strip has disappeared. And if I want to rename the PS delete, is the same thing as the table or the view. PS delete with the new name ps.point2. Okay? Refresh my storage procedure, and now the new name is PS2. And like the table, I think you understand, it's like the table, like the view, drop procedure PS delete 2, because I've renamed it just before. Okay, it's I can delete it. I must to put some square brackets, and if I will discover it, it's good. Okay, drop procedure. So you can do whatever you want in the storage procedure. You can do create procedure with the name as you want. You can put millions of rows of code. Storage procedure are extremely powerful. Okay, I strongly advise you to work with them. I strongly advise you to work with them when you are doing large transaction batch. Okay, but everything in storage procedure. You will thank them later, especially on the performance side. This is not the point of the topic, but it's to guide you towards good decision if you want to drift into a DBA career. Okay, I will talk about that in other trainings. Okay, so let's go for the next demonstration. How to declare a variable in a storage procedure. In SQL Server, local variables are used to store data during the batch execution period. Okay, variables are declared within a batch or procedure with the extension declare. Okay, and the set or select statement assign values to them. So first, to declare a variable, you must first write a declare. Okay, with an @sign. Okay, followed by the name of the variable you want to give it. For example, I will choose Skywalker, for example. Skywalker. Okay, And of course, you must give this variable a data type, for example, a varchar 20. Then you must give a value to this variable, for example, with a set. I will write Luke Skywalker. And to see what this value gives you must, of course, affiliate a print of my variable Skywalker. And if I run this query, I forget my variable just here, and you can see that my print returns Luke. Okay, Luke just in my variable here. Little trick, you can remove the set and put the value just here with equal. Here, remove the set option and run this query. You can see you have the same result. Okay, we have removed the set. Okay, but according to some developers, it's best to put the set for a better understanding. Okay, so let's create our first storage procedure in which we will assign a variable. Okay, for this example, I will create base with one variable, declare with John, and set the type with varchar 20, set at John McEnroe, the famous tennisman, and at the end I print the variable. Okay, so let's create our fantastic procedure, and if I'm running this storage procedure with one variable, you can see that it's McEnroe. Okay, so next demonstration we are going to play with the contact table on the first name column. Okay, we are going to play with the first name column: Michael, Liz, Kelly, and so on. So let's create the procedure with the variable first name. So I'm going to create a storage procedure where I am going to do a select on the first name column. Okay, and I create my procedure, and instead of declaring the variable inside the code, I can declare it while creating the procedure. So every time we call the storage procedure, it will call the variable that I assign to it in the first name column. Okay, so let's create the storage procedure, and if I run the storage procedure with the name of Bruce, so I call the variable first name when I'm running this storage procedure. Okay, understood? So execute with the first name equal Bruce, and you can see that it returns two rows for Bruce Willis. Okay, I can change. I can put Brad and my friend Brad Pitt appears. Okay. So can we insert a variable in a view? So in this example, create a view with a variable first name, select from my contact table where first name equal the variable, sorry. Okay, you have a error message, must declare the scalar variable at first name. Okay, you cannot use variable in a view. You will often see variables in storage procedure. So it was important to demonstrate this. I hope that now it's clearer for you about these famous variables. Okay, so let's go for the next demonstration. The scalar function. SQL Server scalar function takes one or more parameters and returns a single value. Okay, the scalar function help you simplify your code. For example, you may have a complex calculation that appears in many queries. Instead of including the formula in every query, you can create a scalar function that encapsulates the formula and use it in each query. Okay, so the scalar function will return a value. To create a function, I think it's not very difficult. Okay, so let's go create function and the name on my scalar function, so scalar function. Okay, with parentheses with a variable. So for the variable, let's type Batman with, for example, Bashar 2000, and we put a second parenthesis to close the query. And for a scalar function, we must to type returns for the Bashar 2000, and let's write the as like a storage procedure, begin and return. For the example, just the substring with the name of my variable that I declared before, Batman. Example, just 1 and 3, and the end. Begin. When you have a begin in transact SQL, sorry, you have always a end. Okay, remember this: begin and end. So for now, we told it each time we call this function, it will do a substring of the value in Varchar 2000. Okay, that will start with the left value at the start of the string. So the one here. So and we is going to stop at the third character on the right. Okay. So let's create the function, scalar function, and you see that the scalar function is in the programmability, section, function, and scalar valued function. Okay, so my scalar function is just there, dbo scalar function. Okay, so how I am going to call this function? I just do a simple select. So let's run the select with the schema, dbo, and the scalar function. You can see that's very simple to call a function and the parameters we want to give it. For example, Marvel. Let's run the function and we can see that the substring of 3 stopped at mar, M-E-R. Okay, so it worked fine. So, okay, so there you go. In this demonstration, we created a scalar function that will return a value relative to a given string of character. Okay, and if we put, for example, just a null, it will put a null. Okay, so know that if you put a null in the scalar function, it will put always a null too. Okay, so let's go for the next demonstration. A table function. Table type function are what we call inline type function. Okay, we can create a function as if it were simply a table. Okay, let's go for the creation of the function. Create or alter. Okay, create or alter is new in SQL Server 2017. Okay, let's continue. Create or alter table function. Okay, it's the same syntax that the scalar function. So return with the variable test and return and with the type of my variable 200, sorry. Okay, let's continue. So returns me a table, okay, as return. I prefer this syntax. And let's write my code. So gender, count all the gender in my table contact. So make as number from contact. Okay, where my variable test equal. So I think you understand gender. Okay, and of course don't forget the goodbye, otherwise it doesn't work. And let's write the second parenthesis to close my query into the returns. So here we did a table type function. I forget the function just here. Okay, let's create my function table. Okay, it's done, and if we get a look on Management Studio, you can see that there is my table function that has been created. DBO table function. Okay, and if you want my query inside the function without the where to understand the demonstration, you have two results: female with 8 and male with 14. Okay, so let's continue, and now we are to call my new table function with the parameters male. Okay, I think you understand. If I call my table function, you have just the male, which is appears. Okay, and if I change with female, it's working perfectly. Okay, you have female which is appear. Here we saw the table type function demonstration. So let's go to the next demonstration. Sargable. What does the term sargable mean in SQL Server? It's a term used to designate performance on SQL queries. It's an English term meaning search argument able. Okay, that is to say that it's able to use a search argument. That is to say, when we say that a query is sargable, it means that it will use an index, so the response time will only be better. Okay? In a query, when using an index, the data is sorted better on the table. So the data is returned more quickly. Anyway, we will see that after, okay? And if the index is not used, we will talk about scanning the index, therefore scanning the whole table. If it's a small table, it will not be a big problem, but if it's a huge table, here you can see that the performance can drop. So the arguments that are not sargable, we have the like percent following the value, okay? The like percent value percent, not with the name of the column like, column and following the not exist, and where function with the name of the function following the value, equal value. And here we have the clustered indent scan plan at the top on the back. You see the arrow at the top. Okay. On the left, it means that it will sweep the whole table that is requested by you SQL query. Okay. So what are sargable? What we search, are sargable. We have or and the have, the in and the not in, the between, the like value percent. We don't put the percent before the value, just value following the percent, okay? Exist and all comparison operator, okay? And the colon equal function with the value, okay? We see in the logical and, not between. We see in the logical operator of the execution plan on the query which is sargable, that the arrow goes from top to bottom. That is to say that he will not read the whole table, it will directly scan the data which will be sorted and returning very quickly. We are going to have all that in this demonstration so that it's much clearer for you. Let's go to the sargable demonstration. Let's go for the demonstration about the sargable terms. We will start with the research that is not sargable, use formation database, and I have already create two index to see the index scan. However, we will use it or not. So what research is not sargable? Sorry. We will take, for example, the like with the percent value. Percent value with Mike, just here, okay? Let's run this simple select. We have no result, and if I check with in my execution plan, we see that here at the level of the execution plan, we do a scan of the index. That is to say that we will send the row which is at the top and to the bottom right. Okay, that means that all the rows are read. Okay, and if we check the estimate of the number of row reads is 22. Okay, so it reads all the table, all the rows into the table. Okay, so actually all the rows were read to return the value. We are now going to work with the percent value with Mike percent with 2%. Let's run. We have 2 rows, 2 results, and we have the same execution plan, index scan. Okay, so we see that it will sweep the whole table, still the same logical operator. Okay, not like, it's also not saggable. Okay, it's the same logical execution plan, logical operator, index scan. Where function with, for example, here, just here, with the name of my column and this date of birth. Let's run and you can see that it's exactly the same logical operator. Okay, index scan. And for the convert and cast function, we have the same logical operator. Okay, index scan for the convert, index scan, and also for the cast, just there. Okay, so you have to see at your query level if you really need to use the like percent over like percent value this way. Okay, so fortunately we have a research that are saggable. Okay, earlier we talked about the percent, like without the percent at the beginning of Mika, but at the end we can put a percent. And if we check the execution plan, you can see that the logical operator has changed. Now it's an index seek. Okay, and if you check on the estimate the number of rows read, it's now 2. Okay, don't forget that for the index scan it was 22. Okay, let's try with like value and nothing. Let's run this both query in the same time, and you can see that with the nothing and the liked without the percent into Olivier, it's good. It's index seek. So this argument, this function are saggable. Okay. Same thing for the operators, difference in and or. Let's run this 3, select, and we have the same execution plan, the same logical operator, index seek for the in, different, and the or. Okay, between value 18 and 30. Okay, between and not between are also saggable. It's important to remember this when you are writing your first query. Don't forget this syntax when you are writing your first query. Sorry. Okay, so you can see that between and not between are saggable. And to finish for the operator comparison operator, I run this 5 query in the same time, index seek, index seek, index seek, and index seek, the same logical operator. Okay, greater, equal, greater and equal, lower and lower, lower and equal. Not saggable, becoming saggable. Sometimes we have some tricks which allow us to turn the non-saggable to saggable. I will take an example. I usually write this query by this way, where here with the date of the column, and just below I rewrite this same query and put the 1 January, okay, until, sorry, there is a mistake, I change with the 31. So why not to faint at telling we take the values between the 1 January, okay, 1176, until the 31 December 1976. Okay, so we change the year and rewrite with these two new values. Okay, and if I run this query, you can see the magical tricks to rewrite a query. Sorry for the zoom, and you can see that my second query takes the index seek, okay, and the first query with the function here takes the index scan. Okay, as you can see, we fainted the SQL engine and turned non-saggable to saggable. Same thing for the cast function. Here we can paste cast in front. Okay, always try to remove function in front of the where, just here. Okay, otherwise it will never be saggable. So here I took out the function and I put the column just after. Okay, it's a magical trick. So function cast, and you can see that for the first query it's an index scan, and for the second query it's an index seek. Okay, same thing for the convert. We took the convert function and we just copy and paste the H colon before the function. Okay, and if we check the execution plan, is the same result that the cast option, index scan and index seek. Okay, so if you can avoid working view function, or you can rewrite them, you will see that your performance will be doing much better. Okay, and remember all the arguments that are saggable, like nothing and so on. Okay, and also remember, it's very important those that are not saggable. Sorry. So be careful, and I hope you have good performance with your request. So let's go to the next demo. The schema. This is something you will often see in SQL Server by creating a table or store procedure or view. Okay, maybe you never paid attention, but schema exists on tables by default and also on store procedure view or SQL Server object. Okay, so we are going to do a little section about the schema. So what is the schema? We can consider a schema as a bag, okay, where we will put all the objects in it, okay, be it a table, storage procedure, view, and so on. Okay, so a schema is like a bag where we put objects. You will understand. You will understand why afterwards. Okay, we can also consider schema as a sub-basis. It can be convenient to divide your base into several parts in order to manage these different parts separately. Okay, schema are very useful for security or SQL Server. We will do a demonstration to better understand, and you must to know that the default schema on SQL Server is DBO. Okay, if you create a table and you don't put the name of the schema, it's DBO by default. Okay, usually software package create their own schema to separate their tables from tables in the schema DBO. Okay, so we can say that a schema look like this. I have a schema on the left called schema, and when I go to create storage procedure, table or view on the right, you can say that these objects are going to be put in this bag. Okay, so storage procedure, table, and view are going to be put in this bag. So we will see in the demonstration to make it clear for you. Let's go for the demonstration concerning the schema. Okay, let's go for the demonstration about the schema. I use my database formation as usual. As you can see, the syntax is simple to create a schema. Create schema with the name of my schema. Okay, you can see it's quite simple. Okay, so let's create the schema. It's done, and you can see that the schema on SQL Server are in the security section. Okay, if I do a refresh, schema on the security section, schema, and you can see that Star Wars schema has appeared in my schema section. Okay, so here I'm gonna to create a table that will be linked to this schema. So create table with the name of my schema before the name of the table with the point. Okay, schema and the table that I want to create with the name of my column 1, a simple column. Let's create the table with the schema Star Wars, and if I do a refresh on my table into the formation database, you can see that the new table Star Wars Skywalker is appeared. You can see that it's different compared to the other tables that we created in the previous section. So the DBO schema is the default schema when created a table. Okay, you can see the DBO schema by default when you're creating a table. It's very important to remember about the schema. So we insert a value in this new table that I created. And to remind you, when we create a table, if we don't put a schema default in front of the name of the table, it will take the default schema, which is DBO. Let's go for the creation of a view. You can create a view with another schema, with a specific schema. For example, I want to create a view with a specific schema. Okay, let's create this view, and if we refresh the view, you can see that the Star Wars view with the schema Star Wars view Dark Vador is now created. Okay, and if we look at the view, select from Star Wars, my view Star Wars, you can see that there is just one more. It's working perfectly. Remember, you can also create a storage procedure with a different schema, like the view. The great advantage of schema is the security. Okay, it's the big advantage of the security schema. I will create, for example, a user called Obi-Wan with the password. So we 1, 2, 3, 4, 5 until the 9, and let's create Obi-Wan user. If you want to see where is your friend, it's Obi-Wan, it's just here. Okay, I create a new user on the SQL Server, on my SQL Server security, sorry. And I'm going to attach the Obi-Wan account to the database. Now you can see that Obi-Wan is now here. Obi-Wan can access to the formation. And to finish, let's give Obi-Wan the right to this account. Grant select on schema Star Wars to Obi-Wan. He will have the ability to just select the table on the schema Star Wars to just on the schema Star Wars. Okay, come on, I will give him the right to the schema. Okay, it's good, and now I will log in with his account on the new Windows. So let's go for the new Windows. No, it's the another Windows. It's this Windows, and I'm gonna to connect with the Obi-Wan account. So let's go for connect, just here, connect database engine, and let's this formation and SQL Server authentication. Okay, just choose this option and we type the Obi-Wan with the password 1, 2, 3, 4, 5, 6, 7 until the 9. Sorry, it's not the good server, I think it's this one, and retype the good password. And now it's good. Now Obi-Wan is connected to the SQL Server on my SQL Server. Okay, so now let's make a right click on the server, new query, and copy and paste the script. Okay, you can see on the bottom right that it's Obi-Wan that is connected. Okay, let's use formation database for Obi-Wan user account. It's working. Okay, Obi-Wan can connect to the formation database. And what does the select give from the DBO contact? So Nicolas wants to just make a select for on this table. let's run this query, and we have the error message. Select permission was denied on the object contact database schema DBO. Okay? And with the schema Dark Vador, the schema Star Wars, sorry. So let's run the Star Wars select on the Star Wars schema. It's right. Okay? Because Obi-Wan has the good right to the schema Star Wars and don't have the right to the schema DBO. Okay, this is the great advantage of the schema, is that you can give rights to a different schema. Okay, so as I showed you before, we put the object of the Star Wars schema in this bag, okay, of Obi-Wan. So Obi-Wan, we only see the object that have the Star Wars schema, and that is the big advantage of the schema. Okay, so come on, let's move on the next section. Conclusion. It was very cool doing this course. This was my first online course. It was really cool to do this course, so I will surely do more because it was a really, really good experience for me. I hope you enjoyed this course too. Okay? One point I want to share, I hope you have thought about the progress you have made since the start of this course. We'll start from nothing, and then little by little we gain expertise in a lot of things, especially on Transact SQL. So think about the progress you have made. It's very important. Okay? Regarding SQL queries, you have to retype them many times to fully understand Transact SQL, which is the default language of the SQL project. SQL is a very rich and varied project. Okay, we only saw a small piece of the iceberg. In this course, we saw the basics of SQL, but this is a project that is very powerful, very rich, and very varied. Okay, we worked a lot more with Transact SQL than with administration. Administration is in general is security, right to database, backup, restore, and so on. I can put some in the next course. So that's why do not hesitate to leave me your opinions on this course, whether it's good or bad. We can always improve, okay? Try to be critical with me to see if there are something that I can improve, okay? Hoping to see you again in other course. If you have any expectation on your side, do not hesitate to share them with me. If you are interested in my SQL Masterclass course or any other course for a price between 10 and 14 euros, do not hesitate to send me an email at olivetone@yahoo.fr. Okay, thank you very much, and see you soon for more adventures together. Okay, see you soon.